decay. Not sure why. Hello, everybody. Turn the music down a little bit. So in a continuation of Fun Friday I was working on before, we're going to go back to object recognition stuff. I'm not sure if this is working, but I guess I'll leave it on for now. Whoops, that's not what I wanted. That's not what I wanted. Oh yeah, actually I am going to go over form topics first because it needs to be done. I haven't answered form questions today, so I think that's what I'm going to do first. So let's go to the latest. Introducing new project, image to SDR. This was Paul's project. Yeah. Okay, this is formatted wrong. I'm going to show you guys how to format if anybody's watching. I'm just going to edit the post. Wait, edit the post. Reformat this. Data formatting is why I'm changing it, and I think I can't tell, is portrait part of the data? Maybe. That's a lot of data. I don't know. I'm going to start right there because I can't tell if portrait is, I don't think it's part of the data. There, that looks better. That looks better. Now you can scroll through it. If this is the SDR, so they're talking about details of this project that I haven't actually tried out yet. Biological constraints. Oh, this is for the community fork. They're asking about what parts of NewPick are safe to pull out. And my answer was well, everything that they listed, for sure. Yeah, everything they listed, for sure. Let me pull something over here. There we go. Sorry, just getting a few buckets in the right places. Oh man, you hear that siren? So they're going to take out backtracking TM, which is fine. Top-down compute and decode, which is fine. Like, to do predictions, you need to do scalar predictions. I think you need decode, but that can be done in encoders, I believe. So, I don't know. And then, should we use them? And then the temporal pooler, which is the old one, with cells 4. Get rid of cells 4. Cells 4 is what has all those hooks to NumPy. So I would say get rid of them all. Why is it that encoders are required to generate similar SDRs for similar inputs? So this is from Will. Hi Will, if you're watching. Yeah. Why is it? It's a good question. Why? It's sort of the properties that we believe sensory encoders are going through. Possibly the best example of how, I already read this, I think, these answers. What is 3 learning rules? What are these 3 learning rules Subutai was talking about? Yeah, growing new connections. Yeah, I think that the answer is consistency, basically. I mean, you can't learn something if you can't rely on similar stimulations causing similar activations in the input. I think that's the gist of it. These are both good videos to watch if you want to understand SDRs. And that I have not read this whole theory or this whole paper on semantic folding, but it looks interesting. It says, yep, I understand that the same input should output the same output, otherwise you could never learn anything. My question is why 2 inputs that are similar should generate similar but not identical SDRs. You read the semantic folding paper. That's an interesting question. Why 2 inputs that are similar should generate similar but not identical SBRs? Well, they'd only generate identical SBRs if they were the exact same sensory input. But if you feel something just barely different, it's got to encode it for that difference. It has to encode that difference, right? It has to be close to the previous one, but not exactly. I think these guys I think this is true for categorical data. Okay, wait. So Will says, I don't understand the reason for requiring semantic similarity. Wouldn't spatial pooling learning happen just as reliably on randomly but deterministically generated SDRs? Yeah, definitely. We've got a random distributed scalar encoder, for example, but it has to be consistent. And it has to still adhere to those same rules. It's not really random. You can start randomly, but then every other thing that's like that has to be consistent with those semantics that you randomly chose initially. Okay. Oh, another couple comments for how can we be so dense. This is the machine learning paper that we recently released. I haven't read this version. I have read the previous version, and it's been updated since then a bit. So I still have yet to read this. I might actually read through this on Twitch live next week because I need to read it. I want to go over it, and I could comment on it as I read it if that's interesting to anyone. That's something I could do. Okay. Okay. Let me get to a post from Mark here. Okay, so here's, just for the context, trying to understand basically HTM and the model of cortical columns in HTM. A single neuron in a given mini-column gets inputs and outputs of every neurons in mini-columns of the given cortical column. That's sort of, it could. I mean, the key thing about this is that it's configurable. Like, every layer can potentially be input to one or many other layers. It seems like some of that type of fanning out is happening. Clusters of cells. Yeah, hopefully you'll. So I posted also a link to this video, which really kind of, I think, explains the cortical column pretty well. Okay, how can a pattern shared in different cortical columns be predicted while cortical columns do not send information to each other? First of all, they do send information to each other. There are lateral connections in layer 2 that are sharing information to each other, and I know Mark knows about these. I mean, maybe my first letter is encoded in a cortical column and the second letter in another cortical column. No, see, they're all going to be encoded in all the columns. When you look at a letter A and then you look at the letter B, the same cortical columns are looking at that letter. It's not like the same cortical columns in V1 are looking at it. Mark says, this is an excellent and perceptive question. Due to how humans like to break down problems and combine them back together in disciplines such as engineering or physics, we're used to seeing hierarchy in a way that combines and condenses information as you ascend the levels, right? That makes sense. That's a very classical view of hierarchy. It's a very structured view. The lower levels feed into the higher levels. Those higher levels get information from many children and somehow make sense of them and create their own picture of the world and send it up to another higher level, which does the same thing. So the same process. Hi, Falco. The same process is happening at every level of the hierarchy, essentially. Who do we got here? Falco and BitKing, thanks for joining. And so anyway, I'm going through your post here, Mark. I'm agreeing with everything so far. So we're used to seeing hierarchy, like we just said. This leads to a central command and control node, somewhere towards the top of the logical structure. Right. This is a classical view. Much of the classical literature assumes that this is what is going on in the brain and presents this as a fact without any actual support from the known wiring of the brain. When we try to apply this model to the brain, we can see, in case anybody's reading along with me, when we try and apply this model to the brain, we can see there are layers of processing, but the wiring just does not support the concept of information merging into some central node. Absolutely. Jeff has talked about this for ages. He always shows the picture of the monkey hierarchy, right? Monkey neocortex hierarchy. This is like a famous picture. I'm sure there's an image of it. Wiring or something. No, come on. Neocortex wiring connections. Connections between regions. That's it. Connections between regions. Where's the picture? It always pops up. Maybe somebody could help me out here if they find it. It's just like a jumble. See some Hubel and Weissel stuff. It's just a jumble of, gosh darn it. It's always in his presentations. Anyway, it's a jumble. It's hard to say. Okay. It's hard to grasp. Oh wait. Where was I? Right. It seems to stay mostly in a. Doesn't support the concept, right? It seems to stay mostly in a parallel format as it courses from area to area in the brain. I struggled with this for the longest time. It is hard to grasp, but it seems that the recognition is distributed as a cooperative effort using short-range lateral connections through each area of the brain. This allows the individual column to recognize its possible bit of the overall picture and vote with its neighbor on which of many possible larger scale things that it may be a part of. All the computations are local, but they build to a global picture. It's exactly that's perfect. With sequential recognition, so we're talking about temporal, like over time, right? This is requiring movement, I think. Well, from the Minta standpoint, sequential object recognition requires movement of sensor through the space, movement through the sensory space. So with sequential recognition, the bit that is being voted on is also the transition between this current pattern and the next pattern. This adds temporal recognition to the spatial recognition. So I think when we're learning new objects, I think this is correct. That's the bit. We're going to be predicting, given our experience in an object space, just in space. I really think there's probably two spaces, like two spaces in your brain. One space where you model your egocentric surroundings. I think I've talked about this before. And another space where you model objects allocentrically. And yes, as you're moving through object space. So there's always an intersection of these spaces, right? I think this has to be happening somewhere. This intersection between these spaces where you've got your egocentric space and the little peaks, the allocentric objects can pop and render and exist in that egocentric space. And we can sort of seamlessly merge the two spaces. That's like a core thing our brain's doing. It's seamlessly merging the spaces. And so as you move your senses through what you perceive as egocentric space, you're also moving through allocentric space. So you're learning up object models in another space, not your egocentric space. When you're learning object models in a different space, I think. But you have to use the sequential recognition to build up those models, I think. And so yeah, that makes sense to me. And then once you have built those models, then you can use them to recognize, bring up, trigger these objects based on a single sensory feature. Then you can imagine. It's not even imagine. It's not like it consciously happens. It's when you touch something in a space, no matter how even with just one touch, you can fill in the rest of it if you have enough experience with those sensations in those points in space, right? Like, I know this is some kind of cup. If I accidentally touch it like this, I don't know exactly. It could be a coffee cup. It could be a long cup. It could be a beer glass. I don't know. But there's a ton of things that I would drink out of that would match that sensory, input that I get in object space, in some object space. But there's this. Okay, I'll keep going. In the example you provide, the eyes move around and keep placing a group of letters in the center of the visual field. There, this macro column recognizes a letter, and the next macro column recognizes a different letter. They're forming a guess that this is part of a pattern, in this case, a word. So I see what you're saying here. Let me go back. So for example, if I'm looking at the word second here, and I look real close, and if you put your thumb out to in front of you, like this, and you look at your thumb, that you're basically the size of your thumb, that is V1. Like that field of view, the size of your thumb, projects to V1 back here. And that's like the most densely packed area of processing that's going on is in that space. So when you look at that word, the word second over here, and I'm looking at it too, my whole V1 is right there. Like that's about perfect. That this size that I've highlighted right there, that's my V1 where I'm standing right now. So I can scan my V1 all over, and there's a bunch of macro columns in V1, right? So all of them are working together to recognize the individual letters, but also the words. I mean, because that's part of it too. You have column, oh God, hold on. I gotta mute my... Okay, I finally got my audio separated out so I can have desktop audio and mic audio. Anyway, what I was saying about, yeah, I'll just keep reading because I think you're on the right track. There, this macro column recognizes a letter, and the next macro column recognizes a different letter. They are forming a guess that this is part of a pattern, and this depends because you can focus on a letter or a word. Usually, when we're reading, we're reading words, not letters. But they're forming a guess that this is part of a pattern. In this case, a word that they have learned. So these two columns are voting on a two-letter digraph. The second and third macro columns are likewise voting on a different two-letter digraph. This process is happening all over the entire visual field at the same time. None of the macro columns know they're part of a particular word or phrase, just a little bit that they see. Right, so if, for example, one of the macro columns is just covering one letter, it might only be able to recognize that one letter, and there's another beside it that might be recognizing a different letter. And now, in that case, they're going to be operating on different objects. They're going to be passing, they're not going to be, I'm thinking about scale here, you know. And I don't know, I mean, there's a lot about the hierarchy we still just don't know. So, I saw Turba's comment about the shirt, yeah. Daisy. That could be a good audio thing for the for my stream, Daisy. I don't know why I would play it, but whenever we're close to AGI, we'll play it. Okay, they're forming a guess that this is part of the pattern, a word that they've learned. So these two columns are voting on a two-letter digraph. Second and third macro columns likewise voting on a different two-letter digraph. This process is happening all over the whole visual field. None of the macro columns know they're part of a particular word or phrase, just a little bit they can see. Jeff Hawkins described this as looking at the world through a straw. Yeah, the larger local group of macro columns rapidly settle on some pattern that we might consider a representation of a word or phrase. I think that's a pretty fair representation of what Jeff thinks. Yeah, I'm not really sure about this exact part. The second, the first and second versus second and third. Excuse me, because I keep thinking, first there's word recognition, then there's letter recognition. Do I have a Marvin T-shirt? No, I don't. I only have Skynet and HAL. I used to have another one, but I think I wore it out. I'm just thinking about the idea, like, imagine you saw the word second here, and imagine that the C was really an A or something like that, and so you might just breeze over it and not even notice it, right? That's just something that your brain does. You've seen those those things where they say, "Can you read this?" and it's all jumbled up, but everybody can still read it. just because they've replaced things with things that look somewhat like what they should look like. So that tells you there's obviously word recognition going on, and maybe when you're in that mode, you're operating at a level up. I'm not talking for the research team here. I'm talking about how I think this. But maybe when you're doing that type of level reading and you're not focusing on the details, you are sort of operating in a mode that's a little bit up the hierarchy. I'm not sure, but so I'm not certain. But overall, this totally makes sense. The transition time element would change a sequence of changing input patterns into a stable output constellation that stands for an object or word or phrase. Yeah, the idea of that you're moving through an object, and so you're recognizing that as you move through the space of a word or whatever, that it's a consistent pattern. The stable constellation pattern could persist for several eye or hand finger movements, building up longer word groupings as you learn more patterns. Yeah. Keep in mind that each macro column can center on a different mini column that was the winner in recognizing the local pattern. This is where I'm not so sure about. This is sort of, so I think this is an interesting idea. This is one of the things that that Mark Brown has been, one of the ideas that's crucial, I think, central to like the idea of Calvin's hex grids, right? Mark, I think this is like the thing that links it to HTM. If you can think of a mini column as sort of an originator based on lateral connections of the hex grid pattern, or a cortical column could be based around any mini column, maybe something that moves or isn't so discretely defined in flesh, right? So I'm not sure about this. I think it's an interesting idea, but I know that Jeff doesn't think this is true. I think he really thinks there are these physical macro columns, and that mini columns operate within them. In mammalian cortex, this macro column neighborhood, 220, 250 microns, micro columns. This means the center of a macro column is not a fixed place. It depends on the pattern that is sensed. This is true for all macro columns, so the output pattern is not fixed to a rigid location or grid. There's definitely regions, and within a region, so here's what I don't know. If you think about, I think it's very possible that the grid cell mechanism that we're always talking about, and the bumps that we're talking about, grid cell bumps, it's very possible that those are constantly moving through the cellular space. That hexagonal pattern is definitely moving, and I think it's moving in response to either motion or the environment moving or you moving or something like that. Yes, but where's my chat? My chat's not even popping up. Something's wrong here. Other people were having this same problem with chat, I thought. I'm sorry. Hold on. Here we go. Test. So I've been missing chat. Sorry about that. At least they haven't been popping up. But what is the relation to mini columns in HTM? Mini two columns. There's nothing that fixes a column. No, there's nothing in our theory. No, I don't think so. So I mean, it's not something that is really worth arguing about, right? I can't resolve it in my head with our theory, but there's nothing that says it couldn't work that way. It might, but I don't feel like it moves. I feel like, but maybe it does. Now I'm fairly certain that I'm definitely certain that grid cell module bumps, as we describe them, move throughout a layer all the time. They're constantly like moving. I will keep an open mind, but it doesn't make sense to me that you can define a macro column just by picking a point in space and there's a mini column and okay, there's a macro column there, and it doesn't feel right to me. It does feel like it seems like it could be that across the macro column space there's these hex grids that activate across them through oscillatory, something oscillatory, or maybe. Okay, I'll keep going. So, assume. So I'm going to assume this. So the center of a macro column is not a fixed place. It depends on the pattern that is sensed. This is true for all macro columns, so the output pattern is not fixed to a rigid location or grid. This is true for, okay. The output is the constellation of macro columns that won in this competitive cooperative process. So you're describing a macro column competition. Is this similar to, is this through voting, the macro column competition? Each global input state would result in a collection of local output pattern of bits. I have described this as a constellation of stars. I think that's an apt description. Every learned input pattern or sequence results in a different stable constellation. Each global input state would result in a collection of local output pattern of bits. So I'm gonna keep rereading this. I'm gonna keep rereading this until I understand it. So I get the center of a macro column is not a fixed place. It depends on the pattern that is sensed. So in response, so yes, they form from the winning mini columns in local inhibition. Okay. So in response to some raw sensory perception, mini columns activate, and you're saying that from those winning mini columns in some form of local inhibition, these macro columns can then emerge from at least one of, I mean, you only need one mini column, right? And then you apply the hex pattern like you've written about in other posts, I think. So you're saying a sensation can cause a different pattern of macro columns to emerge. So does that mean that that's a part of the object definition, is the pattern of macro columns that emerge? And it doesn't have to be a hex grid. Okay, it doesn't have to be a hex grid. What would the macro column mean again? Okay, that I can visualize that occurring. Each global input state, and when you say global input state, you mean the whole sensory field? Does that mean like contextually everything that's happening around you at once would result in a local output pattern of bits, which represents that global input state, right? Okay. Okay. Yeah, I can see that. See, so here's, okay, I know you, have I gotten to the main point? Because I get this now. Now I'm trying to figure out how this matches with my understanding of how we're constructing a cortical column. Because we're like building it up, you know. Because I'm going to, I mean, we want to understand all the different layers, and so if we're going to say, okay, it's not, okay, I would assume, so you get a constellation of bits, that's an object, right? That makes sense. Assuming all the sensory input is focusing on one thing, and that we're taking that huge dense representation and we're narrowing it down to mini column activations, narrowing it down to macro column activations, and there you have a connection, essentially, that represents the objects across all of your macro columns, each one having different mini column activations. That makes sense to me, totally. Whether or not they're fixed in place, does it matter? Or are you saying that may be the mechanism by which they emerge? I think that's your big point, right? This may be a mechanism by which they emerge, based upon some sensory input. This general process is happening at all levels, so higher levels are perceiving and voting on the groupings formed by lower levels. Keep in mind that this is not strictly a pipeline, as there are huge numbers of fiber tracks crossing up and down these hierarchies and between processing streams. It's not strictly a pipeline. So we're talking about hierarchy here, and when you say pipeline, it's not strictly a pipeline. Are you saying the meaning up the hierarchy, pipeline up the hierarchy? Or, because I thought we were talking about more parallel, lateral. So aren't these, so if this, okay, I know I've been just rambling, but something just popped in my head. If all my senses converge on an object at once, for whatever reason, and so this object is somehow now projected across my cortex in a sense, because of these sensory inputs that have activated mini columns, I'm assuming that the same input wins the same output pattern. Yeah, you have to assume that. That's crucial. So one thing I don't quite understand yet. So let me think about something here. How do these different hex patterns that might emerge in different places in your brain, say for example, I'm going to touch a cup on this side and then a cup on this side. I've got activations happening on both sides of my brain, and in this, with thinking along these lines, Mark, each side is going to have an emergent pattern emerge from sensory input to mini column activations to columns, macro columns. There's more, keep going. Okay, you're talking to me, right? But let me just talk through this, because I think I'm either understanding something better or I have a question that I need to have answered. So if I've got one activation of hex grid over here and another one over here, how can they converge to the same object? Is this... I've done that so many times. I need a guitar stand. This is sensor fusion, right? This is the sensor fusion question. It's always a sensor fusion question. In our, well, I guess you could just vote. I guess you could apply the voting. You just apply the lateral voting to converge on the object, and we could do this using this model that you're talking about. Yeah, okay. We could use that it doesn't really matter how we're describing the column necessarily. I mean, this logic seems to be applicable whether we build a cortical column and say this is this layer and define all the different neurons in every different layer and run it as a simulation. This could be, I still keep thinking, I'm pointing the wrong direction, because I'm pointing to, whoops. I keep pointing over here. This could be useful, I feel like, once we understand how this circuit works, because then we can emerge the circuit. You know what I mean? We can figure out a way to take a big substrate of cells, a huge population of cells, and then have a way to cut it up into these cortical processing units. Is that one of your points, Mark? Because that makes sense. That seems like something that could be applicable down the road. Okay, he's saying keep reading. So this general, okay, great. This general process is happening at all levels. So higher levels are perceiving and voting on groups for my lower levels. This is not a pipeline. A huge number of fiber tracks crossing up and down the hierarchies, and between them, yeah. Oh, I get what you're saying. It's not a pipeline. Yeah. Messy. It's messy. This gives additional things for local columns to perceive and vote on. Yeah, it's totally messy. And I think the messiness is what makes it beautiful. The messiness is what makes it redundant and resilient. You know, you don't know where your input might be coming from. You have to generalize. Everything is forced to generalize. It feels like. Since you're perceiving your entire environment at the same time, these perceptions are likely to be different aspects of the thing you are perceiving. You think of it as like the room that you're in, or the object that you're interacting with, right? Some aspects could be sensor somatic positions, bodies or eyes, and sensations from skin or retina. Numenta's work on explaining how this might work using the 1,000 Brains model. There are many posts on this, and here's some examples. Yes, that's what we're talking about. I'm personally pursuing a slightly different take. Mark, I thought that was a great explanation, by the way. I think you're on track. This makes sense to me, and I know we have differences, especially in resolving the Calvin stuff in the hex grids, but I like this idea. And again, I think I talked about this at the very end of the last hex grid post, that I like the idea. I think it has promise. I don't know how to apply it yet. I think this could really become applicable when we finally get to when we have the compute power to simulate a big substrate of cells, and how can we split them up essentially in real time live, into computing units. Because you don't necessarily want to predefine your computing units, right? You want them to be super flexible. So it would make sense to me if these really weren't predefined and just copied. It was just one substrate that responded to sensory input by self-organizing into these computing units. Does that resolve with you, Mark? So he's taking a different take. See the next paragraph and a little bit at the end. But differs in that I think the information organized into a unique internal structure that I've been calling hex grids. Right. So this is a big post if you're interested in this and this idea of hexagonal grids at a sort of macro column level. Read this post. It's good. There's a lot of good visuals. Some of them, most of them come from this. It's an old book, The Cerebral Code by William Calvin, but then Mark really illustrates it well as you go along with his own stuff. I don't know what you used to do your illustrations, Mark. Let me find some of them. Oh, come on. It's like nothing loading. This was chocked full. It used to be chocked full. There we go. Here's some. So here he's talking about these lateral connections between, where a mini column might originate, how far it can reach, and where it might reach potentially others that are also sort of resonating because of that input and making links with them. So he's got all this really drafted out well. So if you're interested in that, take a look there. Oh, I'm sorry. Good grief. Not even showing my desktop. I'm trying to show these great pictures that Mark did, and I'm not even showing my desktop. So this is it, the HTM mini columns, 2 hexagonal grids. I will put a link to it in chat. Like I said, I think this is really interesting, and I think it jives with the stuff that we've been doing too at Nementa. I think it really does. I don't think there's really anything that conflicts with it. I think they work together well. And I know Mark has been trying to convince Jeff to pursue this idea, and I've pitched it to him occasionally, but Jeff is really focused on, he wants to know what that circuit does. He wants to know what that circuit, he's not gonna stop. He's not gonna stop researching until he understands that cortical circuit, and now they've got the thalamus in there. Hey, Tachyon, nice to see you. And Mark, you're gonna love these 2 podcasts that I recorded. I recorded one with Jeff about time dilation in the thalamus. That was fascinating. Some things I had not thought about at all. And then I talked to Subutai again about the thalamus and his cosine poster on relay cells in the thalamus. So very technical. So I'm going to edit those podcasts and you'll see those soon. Hey Tachyon, I do appreciate that you changed your name. That's very cool of you. Jeff mentioned he was thinking about one-dimensional grid cells. Yeah, he's always thinking about that. Anytime we have a problem that's, and the answer is 2-dimensional grid cells, we always think, can we do it with 1 dimension? And the answer is always yes. It seems like you can solve any dimensional problem in space with a combination of 1-dimensional grid cells. So it's still on the table, the idea of 1-dimensional grid cells. Okay, so thank you, Mark, sorry. Okay. Oh yeah, and we also had this long thread where I expressed a lot of my thoughts about this idea. This will probably blow your mind, but how does this information come together and make decisions and initiate actions? I maintain that the cortex contents are shared with the subcortical structures, the lizard brain. Let's get the brain out. I gotta get the brain out. The subcortical structures in the midbrain, I assume. There we go. I'm gonna leave this cerebellum out. It's boring. It's not boring. I'm sorry. No parts of the brain are boring. I want to finish this paragraph. So these older parts, in an evolutionary sense, and I asked Jeff specifically, is the thalamus older than the neocortex in this past podcast? And he said, I really don't know. It's a hard question to answer. He feels like the thalamus is so intimately connected to the cortex that it might as well be a layer 7 of the neocortex. That's his take on it anyway. The cortex contents are shared with the subcortical structures, certainly through the thalamus. And then these older parts decides and directs actions through projections to the forebrain. Okay, through the thalamus, I bet that's coming from the thalamus. I suppose that if you could say that there was an executive spot in the brain, it would turn out to be the thalamic nucleus. Absolutely. I think that modeling this area will end up being the part that finally makes AI react in a way that we consider having intelligence. High five, Mark. That's absolutely right. That is exactly the track that we're heading. We are really focused right now on the thalamus and trying to figure out how it is controlling attention specifically. How does it shed light on within the cortex? How does it direct the cells? And so you're going to like these next two podcasts because I just talked about this exact stuff with Subutai and Jeff. Absolutely. That was a good answer. Sorry. I know that's corny, but I love to do it. Mark, that was great. Absolutely. Absolutely. When you refer to limitations in size, this is a comment from Turbo. Is that in reference to single machine solutions, or are we still not able to build distributed network solutions? So the problem with distributed network solutions is that we need local connectivity. So you'd have to have all your local connectivity within each node of the distribution. And if we're talking about this type of system where the structure of the processing units is inherent or is somehow invoked by the input, it seems impossible to distribute it across nodes in a physical computer network unless we have very high elasticity or plasticity in the system. So what we really need is plastic chips. We need neuromorphic chips, chips that can grow somehow or somehow simulate the growth of permanences between synapses of neurons. That's what we really need as far as hardware. So the limitation in size that we have right now is absolutely due to compute power and hardware, and also just that we don't have the right type of hardware. So that's a big thing too. You're looking forward to the podcasts. Cool. I need to edit them. They're on my list of things to do. I will bet you one would be out by the end of next week. So, because I really like the one with Jeff. It should be good. Hold on. All right. Thank you, Mark. That was a good post. We're pretty much on the same page here, so that's great. The thalamus is fascinating for sure. Okay. You know what's exciting? This is this is really exciting. I really feel like we're figuring out how this stuff works. Like really figuring out how it works and actually how we might actually build things with it. It's very exciting. And it's taken so long to come up with a picture of what's happening in one cortical column. Like what are these layers doing? And it feels like we're so close because grid cells was a huge unlocking of so many things. And understanding that grid cells and how they map space and how the cortex could be using it to compute and model just opened up so many possibilities. And it just feels like it's going very quickly now. The theory's going very quickly. Falco used to have a friend who designed CPUs for a living. I didn't. So it still sounds as though software solution would be able to simulate, given at a much slower pace to prove. Oh yeah, definitely. We're constantly building software simulations at Numenta to test these theories. All the theories, like if we have a paper that's out, we have software theories. We have software running simulations to test that the theories do what we think they do. BitKing's got a lot of hardware experience. BitKing, you should share that engineering essay that you wrote in the community lounge of the forum or off-topic part of the forum. I think people would enjoy that. That was off-topic. Okay. Cool. That was a great discussion. Thanks for pointing that out to me, BitKing. Honestly, sometimes I see a really long post and I just sort of skim it I miss out on something cool. So I appreciate you pointing that out to me, because I feel like you and I are on the same page for the most part when it comes to this thinking, and that makes me feel good. The more that we can all be on the same page when we're thinking about intelligence, the easier it is to explain it to everybody else, right? So this is kind of exciting too. I won't name any names, but Marcus. I will name Marcus. Marcus was at CNS last week, and he met someone and brought him over to the office yesterday to give a talk. And this was the first time we had a neuroscientist in the office that thought just like we did. Like most of the neuroscientists that we think of, that we talk to, they're so focused on one little thing in the brain, or that little thing in the brain, or that little thing in the brain, and they're not looking at how the cortical column works. Like all our thing is, how does this column work? What are its compute functions? What are the layers doing? And this guy we had in the office just totally was infatuated with the same questions that we have been researching for years. And so it was a great meeting, and it was so exciting to see somebody that was so excited to see what we were working on, because we just spoke the same language. So I just sort of observed that. I was on the double. The best thing is that this does not need hex grids to be useful to HTM. That's true, yeah, that's true. That's true, I didn't think about that. The hex grids, if that works out, it's like a bonus on top of everything that could help just connect everything together, right? I did not interview him or her for the series. I didn't have time to. It was like he popped in the office once. But I have a feeling that you'll hear more from this particular neuroscientist. So stay tuned. Okay, let me check a few things here. I guess it's time to do something. I think it's time to get something done, right? I'm not gonna do the Twitch stuff. What I'm gonna do is the Trello. I'm gonna do the Trello. Oh. I got buttons. I forgot to get buttons. Yeah, ask an off-topic question. If it's Fun Friday, and let me check. Yep, it is. It's Fun Friday. We can go off topic, whatever you want. I'm only going to be strict with off-topic chat on work sessions, which is like Tuesday and Thursday. Well, then no, if it's a boring question, I don't want to hear it. But you're going to ask it anyway, right? It may be an interesting answer. Some boring questions have really interesting answers, like, what did you do last night? Mine was not. I mean, I didn't have an exciting night last night. Here's what I did. I worked on, I tried to work on that research map that I was working on yesterday. I don't think I'm going to put you guys through that anymore. That was a boring, it's kind of a boring project, and it has nothing to do with HTM. It's just like a web post. Are you serious, Film Tire? Hey, look at my Twitch page and go see the poll down there and vote. Look at, I'll show you. I have a poll right down here. When will truly intelligent machines be a reality? And the winning vote is 25 years. My answer to your question is no. No, and it's more like hell no. Not no, but hell no. I would be so surprised if we had anything near AGI. I do think that when we sort of slip past that border, things will happen pretty quickly, but I don't think we're close to having it. I'm thinking more like 20 years maybe, 15, 20 years, something like that. But who can say? I mean, who can say? It's hard. This is hard stuff. And I can tell you one thing, it's not gonna be neural networks. I mean, no. It's definitely gonna be neural networks. It's not gonna be deep learning. It's not gonna be deep learning. And because deep learning doesn't give you this rich layers of this layer doing that, this layer doing that, and all the different interconnectivity that you actually have in your brain. Deep learning is like this layer, this layer, this layer, this layer, this layer, this layer, when it's really all these things in between never mind the fact that, the global aspect of backpropagation doesn't seem to work in the brain, but it's just I think it's just a totally we know it doesn't, like, there's certainly Bayesian properties of statistics and stuff that are affecting everything in your brain all the time. It's a population effect of having millions and millions of neurons and stuff operating at the same time. You're going to be able to look at it from a Bayesian lens, but you can look at anything with a Bayesian lens, and that doesn't necessarily tell you how it works. You have to know how it works. So deep learning doesn't tell you how it works, and even some of the people that are deep into deep learning have a hard time explaining how it works. And with HTM and all of our theory, and you can look at the videos and the papers and everything, we're starting from how does it work? We want to know how it works. And from that point on, once we understand how it works, we'll build something with it. Everything we've built is after understanding how it works. BitKing says hex grids and thalamus for the AI win. definitely that direction. Yes. Mark says he's working on this right now, so 5 years. That's awesome. Well, good luck. I would be happy if it happened in 5 years. So you saw the poll and wanted to hear my opinion. Yeah, I think it's 15, 20 years out. We will achieve it though, because it's knowledge and it's there. It's accessible. It obviously works somehow. It's not magic, so we'll figure it out. Okay, your boring question. When you say you guys, it's really just me. I'm the one jumping between JavaScript and Python, which I should learn if I want to understand. Oh, if you want to understand, learn Python. Learn Python. Yes. Learn Python. JavaScript is nice, but it's not. If you want to be a machine learning if you want to learn the language of the field, learn Python for sure. So that may have been a boring question, but it was super easy to answer. Yeah, the singularity will be in Python with C++ optimizations. All right. Hey, Will, nice to see you. Let's go back to the project at hand now that we're past the forum stuff. Let me check my viewer thing. Does this work? I'm supposed to be able to press a button and it'll tell me how many people are watching, but it doesn't work all the time. I'm only writing in JavaScript when, well, here's the thing, Falco. You're going to learn the logic no matter which language I use. Writing and reading are two different things. You can easily read Python or JavaScript. That shouldn't be a big problem. Once you know the syntax of it's easy once you know how programming works. They're basically pseudocode. JavaScript and Python are dynamic enough that you can read through them, and if the code's written well enough, you can read it like pseudocode. So I don't think it matters what I write. It matters what you choose to write, and I would suggest Python if you want to work in the machine learning space or the AI space. So yeah, Python and JavaScript are pretty close in style, different in spelling. That's just something. Become a polyglot programmer is my advice to you. Here comes Innobeta with the emotes. How's it going? Good to see you. It's going better today. It's Fun Friday, so I didn't put any productivity restrictions on me or anything. So we're just chatting, talking about what we're going to work on now, which I think is going to be a problem to do with 2D object recognition. So I was going to merge two different projects. One of them was this one that had a Python directory that, hey, I remember you, Erebus, thanks for coming back. You helped me out with Python at some point, I think. He says he's fluent in C++ and Qt, but I know, yeah, I can understand all that stuff. Yeah, those languages are pretty easy to understand, I think. What's on a higher priority list on Dementa's research, the thalamus or place cells? That's a good question. We've been researching place cells for a long time, so I think place cells, probably, because thalamus is sort of, we're just now moving towards thalamus, but we've definitely been thinking about place cells for ever since we thought about grid cells, because when you think about grid cells, a lot of stuff comes along with that. Head direction cells, band cells, border cells. There's a bunch of different cells that are conjunctive that detect certain aspects of space that seem to be conjunctive of other cells working together, other layers of cells or something working together. It's not fully understood. But place cells being one of those that's like a landmark, you know, helps identify things by a particular landmark or something. Film Tire says, what do you think about consciousness? Is it even real? I feel like it's something like soul in Middle Ages right now. Nobody knows how it works, but everybody 100% sure it's real. Consciousness. I really try and bow out of these conversations about consciousness. It's like free will a bit. It's a slippery slope once you start talking about it. I think consciousness may end up to be nothing special. Maybe I want to take that. Hey, yes, do that. Post me the forum, Mark. If you want to talk about consciousness, I got a place for you. Mark's gonna post it into chat. Unless you want me to find it, you might be on your phone or something. But there's a lot of forum posts. There's a lot of forum posts about this. I'm sure I have consciousness. I'm just not sure about everybody else. Have you heard of solipsism? Anyway, look it up. I'm not Googling solipsism on Fun Friday, that's for sure. Okay, we got to get to the projects here. I got to get to some code. So where we were at is I was looking at this. No, I'm not looking at my Twitch daemon. I'm looking at this Python project. Oh, geez, what did I just do? PyCharm. Here we go. Veto ergo sum. I'm gonna find that. I'm gonna find that post. It's really easy. I think. Here, just do this. Consciousness. In general, you can just search for consciousness on HTM Forum and you'll find something interesting. But I think Mark has something as a specific post. I could put this by BitKing. There he is. Search. That's it. It's the thought experiment one. Or is it the not what you think? Either one. Either way, you'll find some interesting conversation on consciousness from Mark Brown right here on HTM Forum. Okay. Sorry, cogito. That's what Descartes said. Cogito ergo sum. What does that mean? I am not sure that I exist. I'm not sure I'm conscious, or I'm not conscious. All right. Okay, Film Tire. Can't say for myself. I believe consciousness is simply a useful construct. Is that what you mean? And that helped us survive, not a real and unique mechanism. It's definitely something that helped us survive. Everything that's going on up here was evolved to help you survive. Everything. Now, it might not play the same role as it used to anymore because society has changed drastically in the past few hundred years. And a lot of those mechanisms don't return the same benefits as they used to. I think therefore I am, of course. Oh, here we go. Here's the forum post. Consciousness versus intelligence. Now, I said I'm not going to get into it, so I'm not. I'm going to let you guys read that because I don't want to talk about consciousness on Fun Friday. It's not fun for me. It's too much. I can't wrap my brain around it. And something I can't wrap my brain around, I don't like to just spin my wheels forever. I need something tangible. I need something I can code. And you can't code consciousness yet. Does it mean that mindless masses of people do not exist? Okay, I'm going to bring this up again because someone brought it up in this thought experiment. Why am I still talking about this? Because it's interesting, I know. So this thought experiment was interesting. There's the Chinese room. But it's basically if you got enough people all together and told them how to act like neurons, and basically at a very slow rate would consciousness evolve on top of that huge mass of people if each one acted like a neuron, you know. Theoretically you could get people to do that. And it's an interesting question. Probably, I don't know. Is an ant colony conscious? It's the same question. It's hard to say. Ask it. You can't ask it. That's the thing. How can you know, hold on. I gotta start using these buttons. How can you know something is conscious unless it can declare that it's conscious? I don't know. I am gonna have trouble declaring anything conscious until it gives me some indication that it's conscious. I guess a cow can't declare that it's conscious. So is it? That's a question. Do we have to have a common language? I don't know. Anyway, I'm not going to think about it anymore. Let's go back to the code. So we were going to, what have we done? We created the object definition schema. The next thing I wanted to do was, create a library of objects for testing. We sort of did that, but we don't have a full library. Merge JS object project with main. Okay, so I'm going to do this. I'm going to merge the JavaScript object project with main, and then we're going to go code. Yeah, I'm going to start coding and getting some fun stuff done here because I'd like to see this work. Let's go to let's just dump it. Let's just move it right over. Oh, I'm actually running it right now. Here's the JavaScript project that we're running, and this is basically just displaying a couple of sample objects that we're creating as a part of an object schema that's going to be a part of an object recognition task that we're going to build in Gherkin. Oh man. Oh yeah, I forgot about this. Thanks for reminding me. This is Will. He's been helping me with this, helping me on both of these projects. So in this one, looks like you have jQuery matches dependency. We're adding jQuery the proper way. All right. So yeah. Makes sense to me. I'm going to trust you on this because I am going to, to parcel. Didn't I already have that? Is this the one that was, no. Git fetch code. Yeah, okay. Git check. I think I already have to parcel checked out. Git pull code, all the things. Okay. And then just parcel static. Just want to make sure that it runs for me. And I'm really only doing this because every once in a while I forget to check in a dependency that should work, and so everything works. And so it's always good to download it and run it before you merge something, just in case. Although it's not like we got a big production team. It's only a couple lines, yeah, so I'll merge that. No big deal. I don't think I need to review it. I'm just gonna merge it. Merge it. I should have a merge sound too. Merge. PR merge sound. I'm thinking about ways of enhancing my Twitch stream, so I'm thinking about the different sounds and things I'm gonna end up adding at some point. Okay, so back to the code. Check out master. Git merge. I'll just git pull update master. Oops. Oh, git pull update upstream master. Oh, I'm in the wrong project. Right. I'm in the wrong project. Git checkout master. Git pull upstream master. Do I not have that? That was like an alias I always used to use. Git pull. I'm working this out. On what language deaf since birth people think? I don't know. Okay, so now that I have this, I'm just going to make a directory down in HTM 2D object model called JavaScript. And then I'm going to move static readme. Basically, I'm just going to move everything, and then I'll clean it up later. Move star dot star. Is that a thing? I've totally forgotten. HTM 2D JavaScript. Did it work? It didn't move it did not move the directories, of course. Okay. Move recursive star HTM 2D. Oh, no. I did it wrong. So you can't do move recursive. Why can't I do this? I'm just gonna do it, move static. JavaScript, there, all right. That was more complicated than it was simpler than I made it. Okay, so I've got my JavaScript thing over here now. Oh, I'm missing something. You know what? What's the YouTube thing you tell me? A moo sound effect. Is that the, that could be the merge? That could be a merge. Okay, thinking in language is an effect of experiencing the world and language. Film Tire, this is not such a crazy language. Maybe you can start this. Yeah. You can start that topic on the forum. It's interesting. A moo merge. PR merge moo. Why not? Because we're moving it. All right. So I've got 2 projects now in one, and each one should have its own README. This one should be the main README. This V&V should be in the Python directory. Yeah, I'm moving it over there. And I'm not going to check that V&V virtual environment in. That's funny. That's funny. That makes me want to hear this song. What's the name of that song? U2. I know it's U2, right? U2. That was on like one of their first albums. The album. See, I'm totally distracted again now, but it's just still moving, so it's fine. U2 has a lot of albums. It was on Joshua Tree. She moves. No, this isn't it. It's not Joshua Tree, is it? You see how easily distracted I am? It might have been Rattle and Hum. Definitely. Desire, still haven't found freedom. Someone telling me. Mysterious Ways. Why can't I find it? Mysterious Ways. U2. There we go. She moves in mysterious ways. I got it. Although I know this video will be demonetized because of this, and it might not even be, you know what, I better turn this off. I gotta be careful with this. If I'm playing like top 40 type stuff, the record companies will make this video, they won't even let me show it on YouTube. So I think I better rethink that and start playing the more eclectic things. Like mellow beats. That's my current jam, mellow beats. Anyhow, what is taking so long? Yes. No, don't search for references. Just move it. Gosh, why did I do that inside of the IDE? Okay, so now I'm gonna have to reconfigure this Python project because this is no longer valid because I moved it. So that's fine. Project interpreter invalid. So I need to delete it somehow. This is invalid, so I'm going to delete it. Now add another one. Add local. And it's going to be in Python, VENV. Of course it's not empty. That's, oh, it's existing. Okay, so I'm just going to copy this. And it's an existing environment. Oh, come on, let me paste. It won't let me paste. Jeez Christ. This is frustrating. Why can't I paste into this path? It's annoying. There's so many ways. Where am I? HTM, 2D object model, Python, VENV. But it won't let me choose it. It won't let me choose it. Why not? This doesn't make any sense. Do I have to say... I shouldn't have to say bin activate. Invalid. Okay, this is stupid. Okay, I'm just going to create a new one. And I'll just blow it away. I'll just blow away the virtual environment. That's what they're for, right? Just blow it away. Remove the env. Did I do it? Yes. Oh, I should probably also deactivate, which, wow, what's gonna happen now? I think I just removed, it still works. Okay, it must have done it in a tricky way. All right, new environment, Python venv, Python interpreter, Python 3. Yep, that's what I want. Okay. And now I need to go into that environment and run the setup. Yeah, that one. Okay. All right, so now I need to go into that environment. There it is. Source, venv, bin, activate. And now I can say pip install requirements .text. And oh, I'm missing some chat stuff. How much noise would you need to add the channel to defeat their deep learning? Quite a bit, I bet. I mean, because it recognizes it when it's playing in the background, even when I'm not streaming it through desktop audio. So what they do is they sample portions of it, and then they do that with all their songs. You know, they train on all their songs by sampling portions of it and then creating like some type of spectrogram analysis. So they take temporal sequences of songs and basically just do frequency analysis on them and put them into a spatial context. And then you've got little bits of spatial context, like little bits of songs that you can compare other little bits of songs to. And if you get close enough, you know, within the threshold, it seems to work pretty well. And I think like if you've got someone talking in it, it doesn't affect the signature of the spectral analysis of the music, apparently, in a way that would alter the spectrogram enough. I don't know. I don't work at Shazam, or I always wondered about that before I understood deep learning, how Shazam did that, because it's a temporal problem, right? Music, but they always batch it up into spatial patterns. From what I understand. Okay. Requirements -dev.text. And how much noise you need to add, I don't know, a lot. Although it's I could probably, if you added white noise, it might really mess it up. So if I just like shh, because additive noise seems to have effect, but deep networks use this thing called dropout to enforce sparsity, and that helps to counter it. But that being said, I don't know. Some level of noise would probably mess it up, especially if it was tonic in some way. What do I think about more modern music? I like more modern music. 2 words on a virtual environment for a newbie like me, please. Sure. So a virtual environment is a Python thing for the most part. I don't know if, I think there's something similar, there's probably something similar in other languages, but you have a system Python installed. Let me use my buttons here. You have a system Python installed at the root level of your computer that's available basically at the system level for all programs or everything to use. And this system place is you don't necessarily want to mess with it too much, because in Python you can pip install X and pip install Y and pip install anti-gravity. And when you do that, it affects the Python that it's installed onto. So if you mess up and install too much stuff onto your system Python, it affects the environment for everything else that uses it. So a virtual environment, or venv, is a way that you can create a virtual Python that has all of its environmental stuff, everything you install, in this one folder. And when you activate it, you're saying, I'm going into that Python environment, not the system Python environment. And it's very helpful. And I think everyone should use it. And that's what the IDE just did, and I think VENV is the... What did that do? I just said VENV, and it went, oh, it went into VENV. Did you know that was a thing? Is that a thing? Tests. It went into tests. When did that happen? When did... Oh, I'm so confused. Wait. PyCache. I just navigated into PyCache just by typing PyCache. When did this happen in Bash? I've never known this could happen. Is this something that's always been there and I just never knew about it? So I'm in my root directory. I just type NTA. I go into my NTA directory. I type HTM 2D object recognition. I just go into that directory. I didn't know that was a thing. Maybe this is a ZSH thing. Okay, never mind. It doesn't matter. I am so getting off on tangents here. So the Python one works. I'm going to test it in my virtual environment. Here we are right now. So I should be able to say, oh, I've installed the virtual environment now with everything it needs so that I can run the tests. This was all just because I moved my virtual environment folder, or I wanted to move it out of the root directory. So now if I run these tests, they should all pass. Great. So these are all of my environment tests so far. Oh, thank you for telling me to switch screen. So I got everything working in Python, and so this is a pain. Now we're going to have competing IDEs. So I can't use WebStorm for this. I either have to use something else for Python or WebCharm. I either have to use an alternate Python editor, an alternate WebStorm editor, JavaScript editor. So I'm going to use Atom, I guess, because I don't know why. So I'm going to have one in one directory, HTM 2D, and JavaScript. And in here, I should be able to say parcel static index, and that should work. And that should be fine too. So both projects are now working in the same place. Now I just want to make sure that the readmes make sense. So I think the, Atom, I'm gonna go down one. This is Atom. So I think this readme this is the JavaScript one. So let's first go up to the top one. Yeah, so I'll leave the origin of the project thing there. And I'm gonna take a bathroom break and I'll be right back because I want to think about what I want to say here. So I'll be right back. I'll leave you with the music on.
the door for me.
Something I can do for you, man?
Is Mia here?
She's busy right now, but something I can help you with?
Oh, I think she's expecting me.
taking a break. I'm still on break. I need a guitar break. Chat amongst yourselves. I just need to rest my head a little. I tell you what, this Twitch streaming is a lot more exhausting than I thought it would be. You're gonna take skateboarding breaks. Why wait till you're 50? Why not just do it now? I feel like when you're doing a lot of very technical stuff, it's really good for your brain to take a rest, to context switch, right? To move to another space for a little while. And even if you're, ooh, that was the one. That sounded awful. Even if you're still challenging yourself, if you're doing it in another context, it's great. It's a great exercise. There we go. It's just good. It's good to work your brain out in a different way. Talking about corporate breaks, doing things with your hands helps resting your head. Definitely. And exercising is good too. Exercising is great for your brain. Good stuff. I can play. Let's see. Oh shoot! Right away. There we go. I don't remember at all. Alarm that keeps going off. Ooh. Excuse me. My wife is online too. What time? Okay. Let's get back to the meat and taters. Okay. Object modeling. Okay, I'm actually. You know what? Don't put it like that. I'm not being paid to play guitar on the internet. I'm being paid to do some stuff, and they allow me to take breaks. Let's say that. Nobody said anything about the HAL 9000 shirt except Turbo, and he liked it. So, and then we had many Space Odyssey jokes. All right. All right, nothing has been done basically except, okay, if we look on the Trello board, hold on, let me see what my wife says. Later, whenever you're done with work. Great. All right. I've been You've been paid to sleep? You mean the band Sleep? You've been paid to sleep. Oh, paid to sleep. Yeah, I can imagine that. Was it for some type of scientific study? Okay, so the purpose of this project is to define object recognition tests. Let's just state that right up front. The purpose of this project is to define 2D, be very clear, 2D, not 2D object recognition with a capital R, recognition tests. A 2D environment. So then we have to define. So here's some topics we want to go through. We want to talk about the object schema, right? And then we want to talk about the Python part. I don't have very good names for this stuff yet, you know. And then the JavaScript part. And some window management here. You got paid for for sleeping because you were doing long hours. Yeah, I've done that. I was in the military. I've been paid to sleep. Okay, object schema. Let's put that first. That's the important thing. So we want to define. I'm not even that concerned about the Python and JavaScript parts of it. Those are just like for people to use to understand what's going on. And maybe there are libraries there that they might use to like load the objects or create an environment, you know, to run their AI on, right? So the object schema. First, we got to talk about an object environment. It's the terminology that's really hard to parse here, I think. There you go. That's better. The terminology is hard to parse because I want to talk about sort of the object environment and the schema and the same time. And when I say the word environment, it's a term it doesn't really mean environment. It's the place in which the objects exist. I want to look at this because so here's an object. Here's an object A, object B, which are poorly named, you know, but we'll invent names that are more eloquent. That's easier said than done. We're talking about such abstract terms already. It's really hard to create a more elegant term for like object or thing or whatever. But I do want to maybe visually show that an object or 2D space has a width and a height. Okay, let's talk about this. Let's focus not so much on terms. I know I'm going to use the word object schema. It's just environment that I'm having the problem using. Yeah, I know. I mean, I could do synonyms all day long. I want to put together a string of words that describe what I'm saying instead of using the word environment. I'm going to say I'm going to get rid of this part. I'm going to say objects 2D or 2D. That's sort of assumed. So objects can exist within a 2D space, so that's true. Objects can exist let's just say objects exist within a 2D space. The space has a width and height. Objects that, well, I think maybe that's all we need to say about that. At each location in the space can be identified with an X and Y integer coordinate. Does that make sense? So I'm just defining the environment within which these objects exist. I've got to get rid of this thing over here. It's just over. Okay, that's better. Let's move. Let's do this so I can see two things at once. All right. Width and height can be different or always the same. They can be different. Doesn't matter. It shouldn't matter. So, yeah, I would say just the fact that I'm calling out that it has a width and a height, you can make the assumption they can be different. All these examples are squares, but I don't think it matters. It's not a restriction. If it's, I will specify restrictions. If it were a restriction, I would say X and Y must be the same, but I'm not going to specify something unnecessary. I think when you're defining a test or a schema or something like that, I feel like everything you say matters, and you have to be explicit only about the things that are explicit. You know what I mean? So each location in the space can be identified with X and Y coordinate. Again, each location may have a feature. Okay, I'm gonna capitalize the important terms. Feature. So then we'll talk about features. Okay, now I'm breaking this down a little. I'm starting to feel a little bit better about this now. Each location may have a feature. A feature is so. I'm just wondering, do I want to link this to sense or not? I don't know. Is a feature is a sense is. I'm not even going to define that. A feature might exist in a location on an object. The feature, so first of all, the thing about a feature, okay, that's obvious, because I just said each location may have a feature, right? Features always contain data, okay? A feature's data is used by the agent. We haven't talked about the agent yet, so let's make something about agency. A feature's data is used by the agent to identify objects. Objects can be defined as collections of features in 2D space. Okay? That's pretty clear. Objects can be defined as collections of features in 2D space. Features always contain data. A feature is just one of the A's in a box of A's. So this, for example, this one, this is a feature, that's a feature, that's a feature, and this is just, these features happen to lay out in this shape in the object space. In the object space. Right, so we're going to say every single, because this is an XY coordinate, this is a different XY coordinate, this is a different one. So each one can have a different feature. I could mix them and match them all day. Features data is used by the agent to identify objects. I'm going to turn this back on. Okay. A feature, I'm going to say always contain data, because why would you have a feature if there weren't something to sense, right? So features always contain data. Features data is used by an agent to identify objects. Let's say, yeah, okay, that's clear enough. A features, the data type of a feature is not established by, I don't know if I want to say anything about data types yet. So I want to make features extensible. I want to make features extensible. So I don't want to define anything about the data type. Okay. Feature initially, I'm just going to put initially all features consist of a simple data type, but should be extensible to contain any data type. I think I'll leave it at that. I think that defines it, because right now we're talking about A's and B's and characters or whatever as being the feature data, but it should be able to be anything we want. You should be able to go to, you know, X4 or Y4 and not just get an A, get a rich piece of data. Not just, it could be anything. Like it could represent red or 17 or whatever. I don't know. So features should be extensible, but should be extensible to contain any data type. Okay, I'm gonna leave it at that for right now. For example, I'll say for example, current object, the current object library consists of simple one character features. All right, so I'll just leave it at that. Eventually we should be able to extend those. Okay. Does this look cool? Is everybody on board? Falco, you got me some good comments, thanks. Now, agency. So here comes the challenge. Let's talk about the object library. The object schema features, now we should say the object library. Object library, which we haven't really created yet. We have them here in objects, but they really shouldn't be here, right? They should be up here. I'll go ahead and move them, and then I can say split out object library from folder. I'm in progress. I like to keep on top of my tools, you know. Let's move this back over. Okay. Okay, object schema, features, and then object library. So what I want to have is a library of different object definitions. For testing purposes, no, I don't even need to say that. The object library can be found in objects. Okay. Each object, each file, each YAML file within this directory contains one object definition in the format specified in object schema above. Okay, and we'll just put an example of the format up here when we get to that. So what we should do is have a training set, right? We create some objects. Should we? Yeah, that's probably what we should do. So okay. So I had in my head several different types of tasks that we could do with this, but let's nail down like the simplest one first. What we should be able to do is have, let's just say, 10 different objects in the object library. We could just label them 0 through 9 or whatever, and each one is distinctly different. So we have to make some decisions. Should we try this first with just one feature? Should we try it with multiple features? If we're going to start simple, we should try it with one feature. I know this sounds like simple, but why make the test any harder than someone could actually make it pass? So what I want is like the most basic ground level test for 2D object recognition that I can create. So I'm thinking these objects are going to be really simple. So maybe I should just do 2 objects. One with one feature spread in some fashion, another with another set in a different fashion. Yeah, definitely test one thing at a time, but that's almost impossible in this case because I'm writing like this broad functional test. I'm starting from the functional test. Unit tests, absolutely, test one thing at a time. But when you're creating a functional test, you have to test lots of stuff. So this is going to test like the whole system, and it hasn't even been built yet. But still, we have to start really simple because I don't want somebody to try and build something overly complicated just to make a test pass. We want to take baby steps. So let's have the test also build it up with baby steps. So while I'm thinking about that, let's start talking about our object library. First 10 objects have one single feature at 10 positions. I'm thinking about something like that. I wonder if we could just I'd like them to be differentiable by humans, first of all. So you can look at it and say, yeah, that's object 1. We could just have it just like 1, 2, 3, 4, 5, and just have a box move. I mean, that's just a box in different locations, or like a spread of features and just in different locations. Let's start with not even 10. Let's just start with like 2. 2's pretty. Let's start with. Shoot, I don't know. Let's start with 1. Let's start with 1. What it would be nice if I had an editor, but I don't want to write an editor for these objects. I think that's a little silly. So what I'll do right now is I'm at a place where I want to create an object model. To do, create object library. And then this says tude. What is up with that? Tude? Okay, so one thing, I gotta get this thing working again because I know it's not gonna work anymore because I moved the objects. So if I move the objects, I'm going to have to change where I'm finding them. So I hope this might not work because objects have to be in static, right? That's where they're expected to be in the static folder. I could put a soft link to them, I guess. I forget how soft links work in Git. If I do a relative soft link within the same repository, I think it might work. We're gonna try it. Okay, so static. Does everybody understand what a soft link is? In operating systems, it's like you can link to a file or directory down one like this from the directory you're in, and it will create you a nice link to it so it pretends like it's actually there. So I can run this web server now, and it's as if that objects folder is actually there where I want it to be, but it's really not. It's down lower. So if we run it now, parcel. Oh, am I in the wrong place? Yes, I am. Parcel static index. Let's see. All right, so that still worked. So now we can go, and our objects are right here, and let's just keep it with A and B. Let's keep it with A and B for right now, and we'll just sort of redefine where these. So we'll take. Why don't we just leave this exactly the way it is? Let's find all the B's. Whoops. No. B. Oh my gosh. B. Replace all the B's with A's. No, let's do X's. Why can't? What's the deal? Replace all. Okay. A. I'm gonna replace all the A's and B's with X's. No, not the little ones. Not the little ones. Case sensitive. Replace all. Okay. Hey, look, it refreshed itself. Nice! Parcel refreshed itself, Will. These could be my legacy objects. Yeah, I don't think so. Hey, check this out. It changed object. Object X. No, this is object A. we'll object A and object B, and here we'll do that and do this, case sensitive. Okay, all right, pop, great. This is again object B, not A. I'm liking parcel, Will, if you're still listening. No, I think he's gone. No, he's still there. You can look and see who's in chat. So I'm just checking. Still Bit King, Code All the Things, Falco, Freeman. Hey Freeman, I didn't know you were listening. And I don't know some of you guys. Some of you guys are always in here. I wonder if you're bots. Not Arabusith. I know you. And Film Tire. Thanks you guys for watching. Tachyon, Ted, Turba. Appreciate you guys being here. Anyway, onward and upward. So I've got two objects. Let's just make this. These are the two objects we're going to compare. We should be able to compare them. So, first of all, I feel like we should give the agent unfettered access. I mean, I'm not going to restrict how they train on this data. But what I should do is define the agent. Define the agent in a way that only allows it to be in one location at a time, and then its sensors get placed. So now we have a few interesting questions to answer. Hey everybody, if Falco talks too much, take care of him. Okay, so let's talk about agency now, because I'm only going to. Oh boy. Yeah, we could totally do this with just two objects at first, because we could say, here's the objects, and then we give them one of them and allow their agent. How many touches will it take? So this is the tricky part, because it might be hard with just two objects, but let's try it anyway. Let's just start simple. We'll start simple with this. That's fine. Okay. So I'll go ahead and specify the format. You can put it real quickly in the README. And I'm just going to show just one feature. All right, that looks pretty decent. So here's an example. And I think I'm going to leave it lowercase. Should find collections of features in 2D space. Here is an example YAML file containing an object definition. Here's an example schema file. Should I call this a schema file? Probably. What are you working on? What are you trying to work on, Film Tire? Here's an example of the YAML file containing an object definition. Here is an example object schema. Let's just say that. Object schema. Containing one feature at 3. Well, let's make it something different. 14.5. 14.5. One feature X at 14.5. Some object. All right, so then we got a little sample of the schema. Features contain data, and so now create object library. So we have two objects. There are currently two objects in the library. Object A, it doesn't matter what they're named. They are completely different, so there's no like overlapping features, but I don't think I'm going to call that out right now. Is there a reason why you want to call your features by a letter? Why not just number them? I don't know. It doesn't matter, right? It doesn't matter. I could change them to numbers if you've got a strong feeling about it, but I don't really care, I guess. I'm gonna set a timer so that I can stop in about an hour or so. Okay. By the way, if you want to know more about HTM, you can go here. And I've got more commands you can try out if you want to know more about the channel or anything associated with it. I'm trying out my Stream Deck thing. This is what you're looking at here. I get to... Oh, it's not pointing the right way anymore. I didn't want to waste time, you know, going over a bunch of weird Twitch stuff, but this is a very cool little thing. Can that help me switch scenes? Anyway. I've got a new toy and I have to show everybody. All right. There are only 2 objects in the library. So the task. So there's definitely going to be something. Whoops. The test or the task. I don't know. We're going to have a task. Test maybe challenge 1. Test challenge number 1. I don't know. I don't know how to say it, but I want to define a test, right? So what are the original NuPic demo objects? Was it a duck, a cell phone? Oh man, you remember that from a long... That was like Zeta 1. I wasn't there. I wasn't at Numenta then. That was an old version of NuPic that doesn't even exist in the code anymore. Like, I think all that stuff got thrown out. That was before sparse distributed representations. What? Yeah, I know. We had a whole vision system, and it seemed to work really well, but they just gave up on it. And it's because, this is crazy, there's a paper on this. There's a paper written by Dilip George and Jeff Hawkins, and it says hierarchical temporal memory in it. But it was like, it's like a bipolar paper. It's like half written from a Bayesian standpoint, that's Dilip George, and half written from a biological standpoint, which is obviously Jeff. And what is this doing? Why is it doing that? That's so weird. Sorry, my overlay is really messing up, and I'm not sure why. Oh, I do know why. I do know why. I have to fix this. I'm sorry. I have to fix this. This is a pain in the butt. All right. Okay, there we go. It's weird. You have to... I'm not going to bore you with the details of OBS Studio. So anyway, this paper, it's like bipolar, right? Half of it's Bayesian, half of it's basically leaning towards HTM. So that old model used Bayesian inference. They didn't call it Bayesian inference back then. I don't even know what. I wasn't even here, so I don't really know how it worked. Okay, but my understanding is that there were Bayesian models heavily in play in Numenta world back before Dilip George left, and Dilip George wanted to pursue the Bayesian aspect of it, and he went and formed Vicarious, and that's all Bayesian stuff as far as I know. So that we just sort of stopped work on that vision thing that got you into it, and focused on sparse representations, because that early stuff wasn't sparse, didn't have that type of stuff at all. There's a thread on this somewhere. Somewhere on the forum there's a thread. I'm not going to go looking for it. I've just decided. I'm not going to go look for it. Okay, so I've got a test challenge, and I need to talk about agency. So the agency bit is tricky because you have to have a location, and then my guitar. Okay, I need to draw. So if you've got a grid, and I've got an agent on the grid, say this is my square the agent's in, right there. I want to define, and this is going to be a hard definition, I think, of the test. This is going to be something that we're going to require all agents have to be the same. They're going to get 4 sensors. They're going to have one north, one east, one south, and one west. They're going to have 4 sensors. Now, I'm not saying this has to be an HTM system, but we're going to set it up so that we could build a multi-column HTM system to do object recognition. Anybody can try and compete with this challenge if they want to, but I'm encouraging people on my forum, on HTM Forum, to try and build agents that have cortical columns with lateral connections. That's the whole initiative of this whole thing, and that's all in this forum post that originated this whole thing. So the agent is going to look like this. If I get it in the right place, this right here, this is the agent. And so it's going to have a location in the space. So now this brings up a couple questions, right? If you think about if this is going to be our agent, we immediately have some restrictions. What happens if the agent is at 0, 0? We have to make a decision about how we feed what do we do with the missing input from those sensors that are not on the map. If we're right here, if the agent's right here, there's going to be missing input. So I feel like we should, I don't want to wrap around the object. I don't think I want to wrap around the object. I want this to be a distinct, well, it probably won't matter. It probably won't matter. It shouldn't matter. We could wrap around the object, or we could just say you just don't get anything. If your sensor gets off the object space, you don't get anything. I think that's simpler. I think this is even simpler. Just saying if your sensor is outside of the bounds of the object, there's no feature there. Then you don't have to worry about adding, subtracting, indices, and it's simpler for people who are trying to wrap their heads around it because they don't have this additional concept of wrapping around and coming to the other way. It's just bounded by one thing. So I'm going to err on the side of simplicity, I think. But I like your suggestions. Don't be discouraged from making suggestions. It's always good to think about things in different ways before moving forward. So I think I'm going to try and put this in words in the README here for the agent. Okay. An agent, capitalize this, an agent can, okay, this is a tricky thing. So an agent can sense objects by positioning itself in a location on the object, and can, let's say, position itself, oh my gosh, can exist in a location on an object. An agent observing, I would say that if an agent existed at a location and an object, it is observing the object. An agent observing an object will receive features in space according to the orientation of its sensors. Orientation's a bad word. Location of its sensors. An agent observing an object will receive features in space according to the location of its sensor. Okay, let's do some ASCII. No, I don't want to do ASCII. What I'll do is, I mean, pictures are good here, so maybe I should just refer to this. Maybe I'll just refer to this SMI agent. Just copy image address. I think it's bang agent picture. Ugh. Agent picture. I think that'll work. Okay. Yeah, that's right. It exists in the object space. Let's say that. It can exist in a location within an object space. Can we say that? That makes more sense? Object space. So it's not really, it's sort of on the object. I mean, when you think about agent, you can also think about finger. And when you're touching something, your finger does exist on that object. So it's in the object space, it's a reference frame. But if it's sort of different with your eyes. Anyway, I think it's a little bit better. Okay. Okay, an agent observing an object will receive features in space according to the location of its sensors. Okay, so I'm going to add that picture. Each agent has exactly 4 sensors. North, and I'm going to be very explicit about this. North, south, east. Actually, the file is the object space containing... Where's my chat window? Oh, it did it again. This is so frustrating. Oh, I know why it's doing it too. Oh boy. It's because like every window, I just made this new scene, and now every window that I bring up on any other scene has to exist here too. So I need to have this alert thing in the right place. You're not seeing what I'm doing here, but it's real stupid. I'm dealing with OBS stuff, and I have to. Otherwise, the chat's not going to show up properly. So give me just a sec. I can fix it so that, or the chat will keep disappearing, and I don't want the chat to disappear. It's not fun. It's more fun to have chat that doesn't disappear, obviously. All right, here we go. Okay, we're getting there. We got there. Somebody chat. I think it'll work. Test. There we go. So it works there. It works here. Works there. Works there. It's right here. Can move it around. I moved it a little bit. That's okay. Okay. Back to the... That's fine because it's an anatomical term. Well, I shouldn't say that. Anyway. All right. Get out of my space. All right. Back to where we were. Agent has exactly 4 sensors. North, south, east, and what was the other one? West. Okay. Each sensor gets... So this is where it gets tricky because I want to start using HTM terms. I want to start using... It's not a big deal, Falco. Like PG-13. PG-13's fine. Testicle, tits and boobs, whatever. As long as we're not just being rude to each other. I want to say proximal input here, but I also don't want to say proximal input. Frustrating about Twitch chat is if you accidentally refresh the page, it loses all its history. You know what you can do is, oh no, you can have a, here, let me show you something. You'll like this. If you are concerned about that, there is a program called, what is it? Twitch. There's a bunch of Twitch chat clients. Twitch chat client. I found one. There's one called Chatty. I have TC. So if you get this, which I'll download it right now, because I downloaded it on my Mac and I used it several times and it works great. So I would recommend this TC. It's a little chat client. You can have chat open all the time to this Twitch channel or any of your other Twitch channels that you watch, and just always be connected to them, and you'll never lose the history. So even like sometimes people come and chat in the chat room when I'm offline. Usually it's me, but people. Okay, I almost just shaved a yak. So you can go get that chat client if you want, or another type of chat client. I'll set up that later. If I had the yak shaving button, I almost would have pressed it just then. Right, where were we? 4 sensors. Each sensor gets, and I'm not gonna say proximal input. I'm not gonna say proximal input. I chat alone. I go into my chat room and I talk to the robot, talk to the demon. I do. I test it out. I say, hey, what's up? Do we have any frequently asked questions? And he's like, here, read them here. And then I go look at them and it's empty. I don't have any frequently asked questions yet. So I'm struggling right now. I want to define the fact that every sensor gets a unique feature from the object space in relation to the location of the agent. I guess that's what I say. Each sensor has access to the feature beneath it. Maybe is that a clear enough term? Feature beneath it. Let's say one space up, or actually just say y minus 1, right? I mean, just to really definitively define this. South is agent y minus 1. Is that clear? South is going to be agent y. Actually, I got them backwards, didn't I? Plus 1, minus 1. I think that's clear. And we'll do agent x plus 1. Agent x minus 1. Okay, just to be declaring where the sensors are. Each sensor has access to the feature beneath it. Together. No, I'm not going to say that yet. At one time step, an agent can be n is minus 8. Oh, did I do this wrong? East. No, east is y. Oh, it depends on. Right. North is minus. North is minus. South is plus, right? X is plus. East is plus. West is minus. I think that's right. N is minus. East is not minus. East is going to be plus. West is going to be minus, but the y's needed to be flipped. That's correct. Because I was thinking about the graph instead of the, it all depends on the space. So we're going to do it this way. Top is, well, maybe we should be like this. Agent plus, instead of doing y and x, we'll just say agent. No, this is fine. I think this is right. I don't know what you mean left is 0. Left is not 0. Left is minus 1 from where you're at. Right is plus 1 from where you're at. I'm looking at this. If I'm at x is 10, y is 9, north would be y minus 1, right? South would be y plus 1, which is what we have here. East would be x plus 1, west would be x minus 1. Does that sound right? That's what I'm looking at. Okay, great. Each sensor has access to the feature beneath it. At one time step, an agent can be at only one location in object space. Each feature, maybe I'll make this part of this paragraph. Each feature. Wait, that's not right. Hold on. Why did it do that? Hold on. I forget how to copy paste sometimes. Each sensor has access to the feature beneath it. Okay. Agents should use their sensors to attempt to identify the object under test, under observation at each time step. Does that make sense? So the agents will move to a location. First, yeah, the time step. I haven't talked about time yet. That's going to be in the challenge, I think. We'll define steps in the challenge. So agents should use their sensors to attempt to identify the object under observation at each time step. So they have an opportunity to identify an object at each time step. Okay. I haven't even defined this stuff. I'm going to put off the test challenge right now. I'm going to commit this because I want to see what it looks like. And then I'll come in and fill in some of the stuff about why is there a Python and a JavaScript. Why does this even exist, you know? Okay, so everything is now running. I want to the get ignore. I'm gonna add this. So get rid of we're adding the Python virtual environment to the get ignore. Hey, it worked. TC worked. Great. I like that. I like that chat app. Actually, that's what I should have up all the time instead of this silly chat thing. Okay. So get add JavaScript and objects. And did it add? Oh, I don't want the dist, so I'm going to go in there and remove the dist. So to reset it, you just say get reset head JavaScript dist. Dist is not something that I want, but I do want to add JavaScript. So I still have all this stuff. I still could have that, yeah? Yeah, okay. Yeah, I got everything else. Anything else I don't want? Oh, I don't want that cache. I don't want that cache. Actually, what I should do here is, let me undo that get ignore. This I will put, oh crap. Actually, that's fine. That's fine. Quit, strong quit. I'm gonna move it. Get move, get ignore. I'm gonna put that in the Python directory, and we'll. Oh, there's already get ignore there. Huh. I didn't know that. Cache. Okay. Oh, you probably put that there, Will. Okay, that's fine. So cat. This get ignore onto that get ignore. So we can combine our two get ignores together and then remove get rm this get ignore. Actually, this one I'll probably put things like ds store. So blah blah. I'll leave that ds store. Whoops. Okay. Into the Python. This is just all cleanup. I'm just cleaning up before I push cache. Okay. VNV VS Code PyCache. This should be another line. Cache PyCache PyTest cache VS Code idea Python VNV. Okay, that looks good. Add that get ignore. Now into the JavaScript. This get ignore. There is no get ignore here, so touch get ignore. I know node modules. Oops. Node modules. What about package lock? You guys that are node engineers, you know how to do node. I noticed that recently package lock started appearing in my node files. Is that something that typically gets checked in, or is that something that goes like only for production to lock things in production? Commit it? Okay, thank you. Just making sure. Okay, and the dist. I want to get rid of that dist. Okay. Oops. Add get ignore. Why is it V and V still there? Did I forget to add it? Oh yeah, that's why. Okay. There we go. Get ignore. Okay. Git add, git ignore, readme. Okay. Git ignore, readme, that stupid cache. So I'm gonna reset all this stuff. Git reset head cache. All right. So I've got my JavaScript git ignore, JavaScript readme, package log package, static index main objects. No, that shouldn't exist. That should not exist. So let's get rid of that. Git remove objects force. One question: what stopped you from starting from a text environment and then building up to a JavaScript or Pygame environment? I don't know. I didn't think about it. I've never used Pygame. Actually, I used Pygame once. But because when you say text environment, do you mean test? I don't understand what you're asking. I'm trying to write an agnostic functional test, essentially, that anybody could create a solution and solve it in whatever language they want. Oh, an ASCII environment? You mean so that I could define the objects in ASCII? I don't think that's a good data format. It's not flexible. I want something. I don't know. It's not a very good. It's not a good flexible data format. Building blocks in Unity. Yeah. So these could definitely be. These objects could be rendered in Unity, for sure. For sure. Yeah, and I did do a little rendering in Unity, but I won't be doing that for a while. But I probably will come back to it eventually, if all goes well. I would love to do some 3D visualization in Unity. If we can get this thing working, eventually it'll end up in Unity. That's my dream for it. For squares and 20 plus something objects can be defined as individual features in space. I don't know. I feel like the YAML schema is just a much better data format than ASCII. It's just flexible. It's easy to edit. It's small. It's a lot smaller. Not that that's a big deal, but I definitely prefer something that looks like this than ASCII. Yeah, it's not important for the project. Okay, there we go. I think this is good to go. And this cache, I'll just add to the git ignore. EI JavaScript. Hey, the thing worked. Awesome. Hey, Hostosis. Interesting name. Thanks for following. I appreciate it. Hey, New Noise Works. I don't know your first name, but I appreciate you coming in here. You're actually raiding. You brought a party. Awesome. Thanks for coming. You know, it's going a lot better today than it was going yesterday, that's for sure. If you're new to the channel, obviously you're all new to the channel. Here's some background and some commands if you want to. Oh wait, I didn't do that right. Commands. I got a chat bot, so if you want to know anything about what I'm doing right now, since you guys are all new, I'll kind of give you an idea of what I'm trying to do here. I am trying to define a 2D object recognition challenge or test in a language agnostic way in a format so that we can apply like a biologically correct solution to it. So the idea is you have an object space like this that's just two-dimensional. This is very simple. Yeah, package management hell. Yeah. So each one of these spaces in here, so this is just X and Y and they're integers. You can imagine this being as large or as small as you wanted. Thanks for the follow, Bitcode, appreciate it. Thanks for the raid too, that's awesome. So there's like two different types of features in this space. So the idea being that you get an agent, and the agent has 4 sensors: north, south, east, west. And each one of those sensors has access to observe a different feature in that object space. And as the agent moves through the object space, it attempts to identify the object. It does sort of look like Minesweeper, doesn't it? It's not. And so the challenge would be to create, and the way this is structured with the 4 sensors, it relates to a biological neural network model called hierarchical temporal memory. And so that's the community that I'm working with to try and build this project, the HTM Forum. That's the forum that we're on here. If you want to check it out, HTM Forum. And that's where this blog post is at. But each one of these sensors, as you can see here, has a complete cortical column structure. Like you're going to model a cortical column. Cortical column is a structure in the brain that has many different layers. And so we're trying to like nail down and try and figure out how intelligence works in the neocortex. So this is a simulation of layers in the neocortex. So we're going to simulate 4 layers in the neocortex. Each one is a sensor around this agent. And we're going to let the agent move through the space and try and feel out these objects. And then tell it, this is object 1, right? And it'll randomly pop through the space and get a feeling for these objects, building up a representation of them through space over time in these cortical columns, in all these 4 of these cortical columns. And each one of them will have an object pool, it's called, where they're trying to do object recognition. Sack of Joy, thank you for following, I appreciate it. I'm talking about neuroscience and AI stuff right now. So this is like one sensor. This would be maybe the east sensor, the south sensor. They all see different things in space, but they all are trying to identify not the features they're seeing, but the object. So the objects are not in this space. Like this is an object. This whole box is an object. And each object has a bunch of features. So we're going to let the agent move through the object space and learn an object, and then say, okay, here's another one, learn it. And it'll go learn that object. And then the challenge is we're gonna give it another object and not tell it what it is, and let it move through the space and see how much it has to move before it can identify the object. That's the challenge. It seems really simple, and the challenge is really simple, but to implement it, as you can see from the moving parts of a cortical column, it's pretty complicated. So this is like HTM theory, hierarchical temporal memory theory. This is like the culmination of several years of work of Numenta coming together in this project. There's 2 different papers involved here. There's a theory of how columns in the neocortex enable learning in the structure of the world. And the second one, which is locations in the neocortex, a theory of sensory motor object recognition using cortical grid cells. And grid cells are amazing. If you don't know what grid cells are, go Google grid cells because they're super cool. So yeah, this is, for the new person coming to this topic, it is really overwhelming. But honestly, it's not any harder than Bayesian neural networks or or calculus. It's something you have to spend some time thinking about because it involves a lot of intricacies of neural, aspects of neurons and connections and synapses and all that stuff. But it just takes time. You can learn anything given enough time and practice and motivation. I've certainly come to that conclusion based on my experience in the field. All right. Okay. So thanks for the words of encouragement. You guys are being nice to each other. This is the team that will one day get the Nobel Prize, I hope. That would be awesome. We'll see. Grid cells, which we're basing a lot of our work on, did get the Nobel Prize. The people who understood grid cells, which is all this location layer here is all based on grid cells. They won the Nobel Prize in 2014. Edward and Christine Moser. They're a couple. They were married. I think they're still married. But they won the Nobel Prize and grid cells are cool. Grid cells are super cool. If you don't know what grid cells are, go look them up. Go Google, check this out. I know I do this all the time. Google grid cells, and the first video that pops up is my smiling face, because I did a whole video on grid cells, and with a ton of visualizations and everything. Like, look at this. If you want to see what grid cells are and how they work, check out this video. It's pretty neat. I'll paste it for you if you want to go watch it offline. But this is like crucial. Understanding grid cells is crucial to understanding sensory motor integration in HTM theory. So if this piques your interest, that grid cell video is really visual, and it might sort of give you an entrance pathway into HTM theory. So it's not any harder than Bayesian neural networks. Yeah, that's true. It took me, it was easier for me to understand HTM than it was to understand Bayesian stuff, because you really have to understand derivatives and calculus to truly get that. And I never took Calc 2 or Calc 2 in college. I am not a mathematician, so I skipped that stuff. But the HTM stuff, the stuff based on biology, is definitely better. And you know, not better. I don't want to say better. Better is not the right word. It's more. It's moving in the direction towards real intelligence, right? Real AGI, what you might call AGI. Single order memory, Matt can even understand. Yeah, that's an inside joke, I think. I took guitar classes. I took a few, but I think I took 3 guitar classes. Are data structures applied to this? Data structures. Let's see. Well, I mean, that's a really generic term. What do you mean, are data structures applied to this? There are data structures inherent in the system, and I mean that I can explain to you, but I'd have to draw out the whole. I mean, here's the deal. If this is a cortical column in your brain, in your neocortex, it's split up into a bunch of layers. More than 6. I mean, they say there's 6 layers, but there's a bunch. And each one of those is like processing something and doing something specific. Each one of those has connections to other layers and different places. Some of them are different types of connections. There's proximal connections, distal connections, apical connections. Some of them are actually spreading out laterally and sharing their information with other cortical columns that are nearby that are doing the exact same thing, and they're all getting feed-forward sensory input from the senses and doing object recognition simultaneously. And the gist of it, that's HTM theory, sensory motor integration theory. And our job as Numenta has been to understand this circuit and what it does, because it's the key common circuit in the cortex, in the brain, I think. And if we can understand this circuit, we can understand intelligence in the brain, and we can build real intelligent things that understand the world, because they model the world through movement and sensory perception and motor integration. That's how you build up an intelligent model, by moving, by constantly testing reality and responding to the changes that you've created in reality. That's an intelligent thing. And that's what this circuit is doing constantly. It's getting sensory input, it's getting efference copies of its own movement commands, so it can tell how it is changing its environment when it does make the moves. So it's kind of deep stuff, but it's super important. And there's also the thalamus over here. Each one of these also like loops to the thalamus too. So a part of this circuit, this would be like, this is all neocortex. And then the thalamus is a super important part of this. And it's part of this cortical circuit as well. And we've recently been thinking a lot about the thalamus. You know what? I got more. Look, check this out. So here's your brain. This is your brain. This is your brain on Twitch. No. So I'm gonna get rid of this part. It's not that important. So your neocortex is all this jazz. And well, some of this is just normal cortex. There's hippocampus back there, entorhinal cortex right around here. This is your thalamus, this football-shaped thing. Okay, so this is like a sheet of cells. You could stretch it out like a dinner napkin if you wanted to. It wouldn't be very comfortable, but you could stretch it out like a dinner napkin, because it has this laminar structure, and the thalamus fits right up in there. Like they work so closely together that we have to understand what the thalamus is doing too. And this is what is controlling attention. This is probably the control. This is the place. This is in a perfect location to control what this does, to control what you're thinking about. What are you attending to? How am I imagining the objects that I've stored in my brain? I also think, well, Jeff also thinks, we just talked about this the other day, that it is also controlling the dilation of time and space. So it has an effect through oscillatory control, by controlling the oscillations across the neocortex, how objects are warped in time and how movements are warped in space. So it is like the culmination of time and space happens right here in these little footballs in your brain. Right there. This is where time and space merge. Yeah, so I keep talking about Jeff Hawkins. He's my boss. He founded Numenta, which is a company that I work for. He was also the inventor of the Palm Pilot, which was sort of his claim to fame. And since then, he has been working on reverse engineering the neocortex. He wrote a book called On Intelligence. You know, I think that there's no such thing as thalami. I think that it's the thalamus and there's two parts to it. Anyway, thanks for the interest. So that's how you first found me, FilmTire, right after the Deep Mind blog post about grid cells. Oh, cool. I'm glad. That's awesome. I'm glad you found that because I put a lot of work into that grid cells video. I'm really glad it turned out. It's one of my most successful video productions. So, yeah, there's a bunch of HTM school videos. No problem. I'm happy to explain. It's Fun Friday, so I don't have to get too much stuff done. However, I could go a little bit longer. Okay. This Twitch stuff is fun, but it can be super exhausting sometimes. Here's the book. Here's the book. Let me fix this. On Intelligence. I don't know if you've seen this. I read this book in 2006 before I even knew Jeff. I picked it up in St. Louis at like Barnes & Noble or something, or it was a Borders, I think. And it was really enlightening. Like I read it and I was like, wow, like it was a mind-blown moment. I was like, this is it. Like this guy's on the right track. And now I work for him. so you can put your mind to it, you can do anything. Because I didn't like try. It doesn't matter. Never mind. Okay. Back to, oh yeah, this. All right, object recognition stuff. I was just about to commit a bunch of changes, and I was going to add something. I was going to add JavaScript. I was going to add a cache, the .cache file, to this. Let's put it at the end. Okay. No? Yeah. Okay. All right. So I'm ready to commit. This took me all day. All day to get to this point where I can finally commit. This is the point where I would hit the button that would do some type of celebration or something. So, yes, I am addicted to Twitch already. Let me tell you a few things about Twitch. I was going to add something to... Yeah, I was, but I'm not going to do that yet. Down here, I'm missing this part and this test challenge. I think I'll come back to it after I commit this, because I hate having so many files not committed. I would much rather commit more often. And I want to see what it looks like on GitHub too, because I'm going to share it on HTM Forum when I'm done. Okay, there's a lot of things that I did here. Merged JS project and cleanup. I guess we'll just leave it at that. Okay, push. Oh, this is going to be push upstream, I think. I think I need to push upstream. Yes, git push upstream master. All right, so I'm pretty loosey-goosey about this version control. Oh, that's not a git command, that's a hub command. Okay. It's actually in HTM community and HTM 2D object modeling. Okay. Here is the code base that we've been working on. Oh, you saw the shirt. You didn't recognize it? I can't do that, Dave. I can feel it. I can feel it going, Dave. It's a Space Odyssey reference. Space Odyssey? Yeah. 2001, A Space Odyssey. That looks pretty good. Okay. So see the origin in the forum post, which goes right here. Purpose of this is to define 2D object recognition tests. The object schema exists in 2D space, height, width at 14.5. I'm missing a period, no big deal. There's an object schema. Features always contain data. Here's the object libraries and objects. And there it is. Just double checking everything. Agency. An agent can consist of a location, object space. Open, open the pod door, please, Hal. That was a great movie. It was a little slow. It was a lot slow, actually, but brilliant. Masterpiece, for sure. Okay. That's pretty good. So let's define the... I might have time to do this definition. I'm sure I do. It's not a big deal. As long as I got people watching, I might as well keep working. So I'm going to talk about... So there's two parts in here for anybody new. I've got a Python area, a Python place in here. I'm just going to keep... Yeah. So my Python place simply has a library with an agent and an environment, and I haven't really done much with this. I've just created just enough of this to write some tests. So we have a two-dimensional environment and create with this width and height, and then we have one of these objects that we could load into the environment, which sets its features basically, and that's super simple. Code All the Things did this actually in chat if you want to say thanks to him. And there's even a test for the environment and for the agent. Let's see. And then the Python or the JavaScript part is just a visualization of the objects. Is that the only code we have? Yeah, it's not even, all it does is just render them to a canvas so we can see them. So it's that simple, I guess. So I'll just describe that. Okay. The tricky thing is, what is the tricky thing? These two different code bases are serving different purposes, and that sort of bothers me. And I almost, I'm going to describe the JavaScript one first because it's easier to describe. Code in the JavaScript subfolder can be used to visualize objects in the object library. So currently it's just, so I'm describing that now because I didn't want to write the visualization code in Python, honestly, because I haven't found a good visualization. I guess maybe I could do it in Pygame. I could totally do it in Pygame, couldn't I? Somebody mentioned Pygame earlier. But right now, the only reason we have two places for the code is so that one of them looks like this. The JavaScript one is showing the objects. That's the only reason. Because I didn't want to. Hey, Tachyon, you've done Pygame. So how easy is it to basically create? It should be really super easy to do this. Like I've got two spaces here. These are just two canvases. Very easy, yeah. So maybe, how interested are you in recreating this visualization in Pygame? It's easy, it's Python. Because I don't necessarily want this visualization in JavaScript. It could be easy in Python. I'm just throwing it out there. No pressure, no pressure. Friday night, let's go wild. Break out the IDEs and the Diet Coke and the Mountain Dew. No pressure. I'm not putting any pressure on you, but that sounds like a great idea because I don't really want JavaScript in here. I just want an example. I just want some type of code example, and The JS was just so we could define the objects and see them and make sure that they make sense. Oh man, if you could Twitch that would be awesome. Matplotlib is not always the best choice. I'm so sorry to say that. Are you trolling me? Is that a troll thing? I don't. I've struggled with Matplotlib many times. I know some of the scientists that I work with do such amazing things with it that I'm like, I know that you can do these things, but doing them, is so hard. Okay. You know what? Let's just add this to the Trello board. Where'd it go? Where'd my Trello board go? That's a good thing to add, I think. Whether or not Tachyon ends up doing it, let's add it up there because that makes sense. So I haven't created a test spec. I have updated that. I have merged that. I have split out that. I have created a library of 2 objects for testing. Yeah, you're not going to get far with a weak internet connection and a bad graphics card. Oh, my sub notification. Oh, did you seriously subscribe? I didn't get a notification. That's for sure. I don't know what's going on. It looks like it's on. Now I have to go check. Well, thank you. I really appreciate that. That's awesome. I don't know what's going on with my sub notification. I'll have to fix it. I'll have to figure it out. Thank you very much. You've got a brain by your name now, and a snow. Maybe that was it. I don't know. What was that? No. Oh, that was my that was my timer. Can you talk a little bit about how you think Nupix should be hooked up to this project? Well, yeah. I'd like to, but not yet. I don't necessarily want to use Nupix. If we're going to use anything, I want it to be Python 3. If we're going to use Python. And that sort of means Nupix out. We could use the community fork. We don't need to use Python also. Like I said, I want to, no, we can't, it's not easy. If we just did an investigation of this, did you see on the forum? Let me show you on the forum. Nupix Python 3. Should we make Nupix? There it is. Nupix Python 3 end of life. So we've basically announced that we are not. So you saw that, okay? You watched all that. We are not going to update Python 3. We still need to write research code. Well, the divide between Python 2 and 3 shouldn't still be a thing, but with people with legacy code bases, it is totally still a thing. And it's not a fun upgrade for those of us who and the problem with Nupix is not just Python 3, it's that it needs to be refactored really badly. Like there's even in the Python code, the stuff that we have to take out to make the transition to Python 3 easier is like it's like brain surgery, you know? It's like you've got to take this out, which means you have to take this out, which affects this, and it's tied to that. It's kind of spaghetti. It's not the best software engineered project. You have to understand all of this code in Nupix came from scientific research. So it's all based on research code that's sort of evolved into being productized in different formats. And so it's hard. So there's definitely still a divide. So we said we're not even going to do it. We have Nupix core, which is C++ and has Swig bindings to Python 2. And that Nupix core we might try and create Python 3 bindings on top of so we can write research over it. That's one option. However, the community, the Nupix community, have already a fork of Nupix core called Nupix CPP. And they've done a bunch of work on here recently to update this so that it doesn't have some of the issues, like it doesn't have swig anymore. They upgraded it so it has pi bind, and so it's much easier to write the Python 3 bindings against this. So we may end up using this instead. So we'll see. Okay. Yeah, all the C bind. So I think this would actually be simpler. And I've talked to Lewis about this too, and he sort of feels the same way. Like if we really want to move fast, we might just take the community fork and start writing research against the community fork, believe it or not. And I know that the guys behind the community fork would love that. But we're still debating it. But everything that is in NUPIC will eventually be integrated into this project. No. There's a lot of stuff in NUPIC that we don't need. For example, again, I'm going to go back to recent forum posts because this has come up recently. Where's the latest? Where's my latest? We were just, someone was, oh, here we go, biological constraints. So I was just talking about this earlier. This is in the fork. These are guys, DMAC and Bresnak are guys that have been working on the fork for a long time. And so they're talking about, should I take out this from NUPIC, backtracking TM? Should I take out top-down compute and decode? And should I take out the temporal pooler? My answer is yes, remove them all. We're not going to be using them. Numenta does not need this stuff. This is old legacy code. We're not going to use it. So the core of HTM still is in NUPIC. It's in the network API and the algorithm, the spatial pooling algorithm, temporal memory algorithm, the boosting, and even the encoders. That's not core code. Encoders are nice to have. Anybody can make their own encoders. So there will be stuff in NUPIC that we don't use. But to solve this problem that we're doing, you don't need any of that stuff. You don't need any of that stuff. You should be able to do it with HTM.js or HTM.java. And HTM.java does not have an OPF, and it doesn't have a top-down compute, and it doesn't have a temporal pooler. So we should be good. Okay, where am I at? In your work, do you deal with low-level stuff like assembly stuff or not? No, we don't. We write research code in Python and then optimize it with C++. So typically there's a Python wrapper around a C project. Do you want me to work with coded images or imported PNGs like the grid and all the symbols? Oh. I don't think you need to work with any images. Don't work with any images. Can you not just draw it and and just use the string definition? Because this is the object you're going to be visualizing. The only thing you have to visualize is an X at 4 or 5. So you could make an image of an X if you want, but it seems like it would be just as easy to draw a text X. Can the community fork be compiled down to something that will run on the GPU? Yeah, I'm sure it can. It's been done with NUPIC core, and so it's probably easier to do with the community fork because they seem to have cleaned up some of the hard things, like the cat and proto serialization stuff. They pulled all that stuff out, so that should be easier if you don't have to deal with that. It's not, no, Falco, you don't quite understand. It's not that only the latest theory, all the theory is in this project. And when I say all the theory, I really mean, let me go back to numenta.com/papers. Everything in this section, all the theory, all 4 pages of papers will be in the project. We don't need backtracking TM. Actually, for anomaly detection, the only thing might be for anomaly detection, you might want to use the backtracking TM. But we're moving away from anomaly detection. So you're right about that. The anomaly detection stuff was not, most of the productization of that included non-biological changes that we're throwing out. We did, the backtracking thing is non-biological, so we threw it out and we're moving forward with just the biological stuff. So it's not just the latest, it's everything, because all the latest theory is built on top of, the idea of thousands of synapses and what are they doing in many columns and spatial pooling and temporal memory. The newer stuff just adds this idea of motor place, location, object spaces, all that stuff on top of it, and the layers of the cortical column. Okay, where was I? What was I doing? I've completely forgotten now. I've completely forgotten what I was trying to do. Update readme with instructions to run sub-projects. That was one thing. Gherkin. Create a test specification. So this is where we're at still. I was going to create another card. That's right. Let's see. Pygame implementation of object schema. Bonus points. Here, I'm going to... Can you see this? Can you see this, Tachyon? Is this... I don't know if you guys have access to this or not. Is it public? Because I will totally make it public if we need to. How do I, you can, okay. How do I add notes to it? Okay, there we go. Edit? Change members? Edit labels? Move, copy, archive? No, I don't want to do any of that stuff. Oh, there we go, okay. So a more detailed description. I'm going to say bonus points for board not found. Maybe you have to log in. That's okay. I mean, if you wanna help me work on it, maybe you can make an account and I can assign things to people. Bonus points for making objects editable through the UI. If you're so inclined to do something like that, that would be cool. One of the things I wanted to do with this was it would be nice if I could, click it and move the feature, to add a feature, change a feature, so you could sort of edit it through the UI instead of touching the YAML. But, that's not totally necessary, just bonus. Okay. You have to log in. All right, yeah, let me know and I will try and figure out how this works. This is my home. These are my boards. Okay, this is not private. That's how to make it private. Invite, view, member boards activities, show menu. Okay, about this board. Members can change permissions. Maybe this is what I want. Change team. This board is a part of, okay, create team. Let's call it Twitch HTM. People on Twitch helping me with HTM projects. All right, cool. Tachyon. All right, so there's got to be a way now. Members. There you are. I think you're on the team. On 0 boards. So I need to add you to a board somehow. Or add the team to the board or something. About this board. Change permissions. Twitch team. Oh, so I have to add you to the Twitch team. So let's go. Twitch team. View team page. Members. Oh, I added you on there. Oh, I think you maybe just need to confirm once you confirm your address. Code all the things. Yes, absolutely. Let's try this. Invite team members. Code all the things. Add to team. All right. Cool. So how do I now? I want to add you and make sure that you can see the boards that I'm on. Hey Will, see if you can edit something, change something, create a card or something like that. I can't quite tell if I gave you the permissions you need. Commenting permissions and members, add permissions and members, allow team members to join. I've got you set to the team. Falco online, okay, gotcha. Okay. Back to the Twitch team, view team page. I think I'm doing this right. Falco online. Oh, invite. There you are. This is cool. I like this. This is why Twitch is awesome. Okay. Team members settings. This team is private or visible to those outside. Slack team linking. Trello business class. No. Members and back to board. So we should have one board on here. And I hope you guys have full access to this. Like you should be able to create a new card. Got to get back to side hustle. See you all in the next one. Thanks Bitcode for joining and thanks for the subscription. That's awesome. You're the first person to subscribe to my channel. So kudos. You can't see anything. What's going on? Is it because it's private? Ah, how about now? How about now? Refresh. I think I just had to change the privacy. Oh, something just happened. Right. What's so cool? I thought you were leaving, Bitcode. All right, so we're all collaborating on the same code, on the same the same code and the same Trello board. So this is cool. And honestly, you guys, if you have any ideas or something, throw them up there, and I'll sort them out the next time I'm online. We can talk about them or whatever. Oh, dude, thank you. That's so cool. I appreciate that so much. So what happened is Bitcode just bought a bunch of subscriptions for people in the community. So that's so awesome. Thank you so much. Yeah. That makes me very happy. And the subscriptions are working now. All right. Let's get the here. I'm gonna take advantage of my custom emote that's finally working. Woo! That's the brain. That's Brian the brain. That's really cool, Bitcode. I really appreciate it. Thank you. All right, now I got a bunch more subscribers, and that's totally rad. Oh man, film tire, you got left out. You know what? I got your back. I'm gonna give you one. You've been here long enough. You've been a repeat. This is you, right? I hope. I want to give it to the right person. Film tire. No, that's not you. It might not be. Film tire. You said no, so I'm gonna stop. If you don't want a subscription. Oh, you wanted to do it right. You're gonna subscribe yourself? It's up to you. Okay. I mean, it's always more authentic if somebody else subscribes himself, but if I've been sort of gifting out subscriptions every once in a while, so I'm more than happy to accept a subscription from anybody. Okay, back to where we were at. You know what I should do though? This board is this is going to be my favorite board. Show menu. You can't do anything to the Trello. Oh, you can't give comments. Okay, what is the problem then? Can you create a new one? Okay, something's wrong then. What should I... Oops, not this. About this board, change permissions, commenting permissions, team members, add remove permissions, all members, team members. Okay, does that help? Hopefully you can comment now. Team members can comment on cards. Oh, so team members can comment on cards, but I guess you can't create your own cards. So I would like you to be able to allow team members to can join this board without being invited. Commenting permissions. I saw something happen. Yeah, I saw a comment, so that's good. Let's go back to the teams page. Maybe team organization public. Oh, I should make this public. Yeah, make it public. I don't mind. Public's fine. But I do want to view the team page. Check something. I can give comments or check something is solved. You can't. I never subscribed to anyone on Twitch before, but you are the right person to start. Thanks. That's nice. Film Tire. I'd like to. What's your real name? It can't really be Film Tire. Okay, settings. The team is private. So there's got to be a board setting, because I want you guys to be able to change, you know, everything. It's all it says is team members can comment on cards right here. It's better if we make suggestions. Okay. All right, that's fine. Yeah, I could make you guys admins. Let's see how it goes this way, because I'd love it if you guys comment all day long, and then maybe during my Twitch sessions I'll update it and with feedback, and we'll see if it works that way. And if that's not working quick enough, if you guys are moving on stuff while I'm not live streaming, then we'll deal with that then. That makes sense to me. Okay, cool. So next up, we still have to actually write the test spec. Your parents are weird on names, yeah. We have to update the instructions. I'm going to put this off, I think, for now, because we might not even have a JavaScript portion of this at some point. And I'm really interested in this gherkin thing. I think this might be the meat of this project, really, is to define functional tests in this agnostic way, especially since we've got our object files in YAML, so anybody can read those in YAML. And then, yeah, so I'm going to look into that probably next before a big chunk of work. So the big things are the Pygame thing, and hey, there you go. He got a test. I could see it. I'll just, can you delete the comment too? I'm just curious. Bonus points for making objects editable. And check this out. I'm going to add tachyon to this. All right. So if you want to work on that, tachyon, that's all you. If not, I'm going to be back. I mean, definitely Friday we'll take another look at this. I've got to do that stupid research map thing. So I'm probably going to have to work on that Monday or Tuesday. So I don't know if I'm going to be able to come back to this until Friday, a week from today. But we'll see. What I will do right now is, now that we have, because I need to wrap up. Now that we have the actual, why do I keep closing this? Okay. Oh no, I didn't. Okay. What is this? Manage topics. I don't need it. I don't need to be more discoverable. I'm gonna just leave it. All right, so let's just make a comment. I want to notify the thread on HTM Forum that we have been, moving a little bit on this. Okay. So I'm just going to reply here, not specifically to Falco, just like a general reply. Yeah, Monday. So you guys, if you're interested in figuring out what we're working on in research, I think Jeff's going to do a paper review or something on Monday at the research meeting. He definitely has a topic, and I'm sure it probably has to do with the thalamus. So Monday, it's like 10:15-ish or so. I will be live streaming the research meeting, and so you'll see my view of the research meeting over my double, and that's on my Twitch schedule. So you can see it on the Twitch schedule. So hopefully I'll have a decent audience then. Okay, so I have been working on this project on Twitch today well, hell, I might call you guys out. Code all the things and tachyon. This repo has been updated with some code and yeah, like commenting on the Super Bowl. Yeah, you guys can ask me questions and stuff, but I'm not going to interrupt them unless, well, I'll still play the role I usually play at a research meeting, which is usually I take notes and ask questions sometimes, but I don't usually contribute much. This repo's updated with some code. That's kind of yeah. We have an object schema defined in YAML. Will says I might have a go at adding a build system that validates code style and PRs for each of the sub-languages. I may also look at bringing in the Java HTM port to hook up an agent. That would be cool. That would be cool. I think it would be cool to have JavaScript directory, Python directory, Java directory, and then because we've got HTML implementations in all three of those languages, and it would be neat to let people work in whatever language that they prefer, because people are going to be more productive in their original programming language or their comfortable programming language. So that I'm all for that, but just know that the code we wrote in the JavaScript part might all go away if we're going to replace it with Pygame, which is fine. The only reason we wrote this code, and it wasn't much code, right? It's really barely any code, was just to visualize the objects so we could make sure that they visually made sense, because I can't look at this and visualize it at all. So that's really the only reason we did that. But that's a good idea, Will. I fully support it. Have some object visualization code in a JavaScript, which might change soon, but anyway. And we have some Python code with an example test environment and object loading, including tests. Please have a look if you are interested. We are keeping the Trello board updated, which is now open. It wasn't before. Keeping the Trello board updated. Board updated as we go. Let's see. Here is the live stream from today. I'm gonna post this, and I don't even have it yet because it hasn't been created. I'll just say I'll post the video of this work session when it is processed. All right, that's it. That's it, folks. That's it, folks. Okay, let's wrap up with a raid. This is cool. This is the first time. This is I had a couple of nice firsts today. First time I've ever been raided by New Noise Networks. This guy is interesting because he's writing a game like Stardew Valley, but it has like a climate change context to it. So I go and watch him, and it's interesting to see the game get better and better as you go and watch him. So you should check him out. And the others first was I got my first real subscriber. And hey, Film Tower, you never actually subscribed, did you? Because I will subscribe you if you didn't subscribe. I think you've been here long enough. I don't know if you're still there, but I can't tell. Who's my? Yeah, you're. Where are you? Yeah, gift a sub. All right, I think it just happened. I think it happened. It's happening right now. There you go. You're too slow. All right, so now I got to figure out how to turn this off. My chat screen just died because of that somehow. Oh well. All right, I'm glad you guys like the stream. Let's go raid somebody. Let's go raid somebody. Let's see who's streaming. This was a fun one. Yesterday, it just wasn't. I just couldn't. I've already raided all these guys. I haven't raided Talk to Me Goose Man. I like that guy. He's fun. He looks like he's playing a game though. I'd rather raid somebody in science and tech. Market research, Fist of Forgotten Game Dev. I've seen him before. He's fun. We could go watch Gitspo. Gitspo. I gotta see him a little bit. Former AAA gameplay programmer, gone indie. So he's working on games. Oh, Radical Heights, Far Cry 4, Far Cry 3, Ghost Recon. Are these the games you've worked on or the games you've played? Oh, worked on. So this guy's live now and he's gaming. Let's give him a few more. Oh, that's fun. Look at that. That's fun. Okay, let's get him a few followers or a few. Let's go raid him. That's what I'm trying to say. Let's go raid the guy. Okay. I gotta get in my room now. Raid Gitspo. 1 viewer is ready to raid. Do I still have a few viewers? 7, okay. All right, you guys ready? Thanks for watching the stream. Again, I will be online Monday. I hope you'll join me for the Memento research meeting because it should be interesting. If you're interested in neuroscience, join me there. Take care.
Hey, thank you so much for the raid. Welcome everybody. How's it going? Let's say Rhino Light, not Rhino Lights. Falco, welcome, hello. I just want to say it like, Rhino Light! Oh man, I screwed that up. That wasn't a good pronunciation. Like the dynamite. Cool, cool. What were you up to? Have a good stream? I was a dev on Far Cry 3 and 4. Not the original Far Cry. But did a little bit. Great stream. Awesome. Glad to hear that. Yeah, I worked at Red Storm for about 7 years. So I worked on Ghost Recon Future Soldier, Far Cry 3, Far Cry 4. Some stuff that got canceled that I can't talk about. AI 2D object recognition. Interesting. Yeah, I've not done any pattern recognition AI stuff. That's always kind of been like a fascinating thing that might be fun to check out if I ever have free time, but I never have free time. I'm actually thinking sound applications would be pretty cool for that. I feel like there's a lot of stuff that could be done to improve sound design. And a little AI work with that could go a long way. Golly, why can I not speak tonight? It's Friday, my tongue's tired.